confirm you all set to go?
Roger, we're all ready.
Okay, we're going to start the activities. Okay, John, Block 3 is done on 1-3. Everything was 2-motor time.
Roger, we copy, Dale. Super.
And also, John, we got TV set up for mid-deck experiment 01.
Roger, sounds good. And Challenger, Houston, I have a small change to your TV pass coming up at Hawaii when you're ready to copy.
Houston, Challenger.
Roger, go ahead.
Okay, we have a repeat of something that happened in STS-2. It must be Truly's fault. When we first came back to the RMS panel back earlier on, I didn't mention it, but the Auto 4 PVI, or not PVI, just the light on the matrix there had popped out. Must have done it during ascent. We pushed it back in and tested it. It's okay.
Roger, we copy that, Dale. Thank you.
Okay, and we're on page 2-2, just making sure all the cameras work there in step 2.
Roger, copy, and when you're ready to copy, we have a slight addition to your TV pass coming up at Hawaii.
Okay, do we need to write it down, John, or is it just something you can tell us?
It's something I can tell you.
Okay, go ahead.
Okay, we lost a little bit of the TV of the payload bay earlier, and therefore for the last couple of minutes of the Hawaii TV pass, we would like you to switch to, or we will switch to the payload bay camera, and if you could configure the payload bay floods for us prior to Hawaii, we would appreciate it.
Okay, we'll do that.
Challenger, Houston's with you at Botswana for 6 minutes.
Roger, Houston, read to clear.
We're at the top of page 2-3.
Roger, copy that.
Challenger.
Roger, go ahead.
Okay, we're through with sample 1, and we're getting ready to start sample 2. MET for sample 2 is 0 days, 6 hours, and why don't you make it 59 minutes?
Roger, copy that, Guy. Thanks a lot.
Houston, CDR.
Roger, go ahead, Richard.
Okay, the RMS testing is going well. We're on page 2-4. We've tested the end effector, both in prime and backup. Dale is now doing phasing checks using backup on all joints.
Roger, we copy, Richard. Thanks. Challenger, Houston, we're going to LOS Botswana in 30 seconds. See you at Indian Ocean in a minute.
Roger, see you there.
Challenger, Houston with you at iOS for 5 minutes. How do you read? Challenger, Houston's with you at iOS for 3 minutes. How do you read? Challenger, Houston with you at iOS. How do you read? Challenger, Houston with you at iOS for 2.5 minutes. Challenger, Houston with you at iOS. How do you read?
Roger, Houston, loud and clear.
Okay, Richard, we're with you for another 2 minutes. We've had some link-up problems.
Okay, Dale and I have completed, or Dale has completed the RMS checkout, and we're just at the top of page 3-2 to start the RMS power down.
Roger, copy that.
Houston, CDR.
Roger, go ahead, Richard.
Roger, John. I've been on and off comm, although I'm in the same configuration that you saw me earlier. One of the guys reported the little Christmas tree of ice over to the right side of the tail, like on STS-8.
Roger, I'll try to get that answer for you, Richard. Right now we're 30 seconds LOS. I'll see you at Guam at 7+29.
Okay. I don't need the answer, but at any rate, there was a little Christmas tree of ice coming out of one of the vents just to the right side of the tail at the base of the tail on STS-2 and on other flights too, I think, and it's out there now.
Roger, we understand, and that's correct. We have seen those on other flights.
Okay, see you later.
This is Mission Control Houston, loss of signal at Indian Ocean Station. Guam in 17 minutes. And following that at Hawaii, a television pass. Combination of cabin TV as well as floodlighted payload bay television. The crew of Challenger was winding down their testing of the remote manipulator system at LOS Indian Ocean Station. The checkout of the remote arm is on schedule and proceeding on time, as are all other flight plan activities. And they're a little ahead of time on sample number 2 for the Cephas experiment. Returning in 16 minutes at Guam. Mission Control Houston at 7 hours 12 minutes elapsed time. This is Mission Control Houston. Less than a minute away from reacquisition at Guam. A brief gap across the Central Pacific from Guam over to Hawaii. We have acquisition at Guam at this time.
Challenger, Houston's with you at Guam for 4 minutes.
Roger, Houston, line clear. John, how you doing?
Doing real good. And Richard, are y'all done with your RMS power down now?
That's firm. We just completed the power down. We encountered no failures. We did see a couple of dynamic things that I wanted to ask about when we get a second here. But we have completed the power down, and the arm is back in and rolled in.
Roger, understand. And when you're ready, I have an attitude and some stars available for you, which you can use later on this evening when you do your IMU align, so that you can do a COAS cal.
Okay, go ahead.
Okay, Richard, down on 4-3 of the cap, to replace the little block for maneuver to the IMU align attitude, you can add to that slant COAS cal attitude. The attitude is roll 173.2, pitch 33.7, yaw 50.9.
Okay, roll 173.2, pitch 33.7, yaw 50.9.
Roger, and use the A1 auto Vern DAP and initiate the maneuver at 8 hours 45 minutes.
Okay, A1 auto Vern and 8:45 maneuver execute time.
Roger, and the -Y star ID will be number 29. That's Alcade, and that will be visible from 8 hours 19 to 9 hours 12. The -Z will be number 22. That's Altair, and that will be visible from 8 hours 30 to 9 hours 18.
Okay, that Altair was 8:30 to 9:18, was that correct?
That's affirmative.
Okay, and I understand you do want to get an IMU aligned, and then while we remain in attitude, repeat the COASCAL based on my request, is that right?
That's correct, Richard.
Okie doke.
And I have one other item for you, Richard, when you're ready to copy.
Go ahead.
Okay, in the DAP book, Richard, on the DAP config B-5, there's an error in it. We would like you to change item 17 to 0.016.
Okay, that's DAP Bravo 5, discrete rate vernier, item 17, 0.016.
That's affirmative, Richard, and this change is good for the duration of your flight.
Okay, well, I got it right here. Let me change both DAP books before I forget it. Houston Challenger.
Roger, go ahead, Challenger.
I understand you want to do a PAMS and the ASC thermal check over Hawaii. Affirmative.
Roger.
Raj, we'll set up for it.
Challenger, Houston, we're going LOS here at Guam in 15 seconds. We'll see you at Hawaii in 7 minutes for the TV pass, and just a reminder for the lights on in the bay, please.
Roger, the payload bay lights are on, and we're all set up, John. And sometime before the evening is over, remind Dale or me to ask you about elbow dynamics in the RMS that we just had a question about.
Roger that, welcome.
Mission Control Houston, loss of signal at Guam, 7 minutes across to Hawaii, and Teeter's satellite relay again, and a TV pass with a mix of cabin activities as well as the payload bay cameras with a floodlighted payload bay. Commander Dick Truly reported that they had the remote arm stowed in its cradle, having completed the RMS power down checklist and a brief exercise with the arm to make sure all of its joints and tendons work. Hawaii upcoming in a little over 5 minutes at 7 days 35 minutes. Mission Control Houston.
Challenger, Houston's with you at Hawaii with a good video.
Roger, Houston, read you loud and clear, and we're getting ready to start the ASC thermal test.
Roger, we copy. And we have a good picture.
Okay, Guy just did the item 1 execute. You should be getting PAM data. And I guess you're seeing the picture of the middeck. Is that true?
Roger, we're seeing Richard and Bill on the middeck.
Okay, let me tell you what we got down there. The flight deck camera is also available. That's the one looking over towards the Cephas. And we have the payload bay cameras all up and ready for you to look at those if you want.
Roger, we copy. Thank you, Dale.
And INCO's got it.
Roger, we have it. Thank you.
Okay, John, we're all going to wander down towards the mid-deck so you can see our smiling faces.
Roger that, and it looks like Richard's trying to give us a demonstration.
Richard's doing a doctor appointment. What he's doing is measuring them. Okay, there comes Guy down the port inner deck access. You can see that we've all grown some white spots on our foreheads.
Roger, we can see that.
And for those of you who don't know what those are part of Dr. Bill's experiments. There are 3 electrodes, one in the middle of the forehead and one by the right eye and the left eye, which he wires us up when we do our EOG eye movements, so he can record that stuff on his recorders. And that measuring device that you saw Richard working, I just got off of that. I've already grown an inch on this mission, so you can get the rockets ready with a contract for when I get back.
Roger, we copy that, Dan.
Okay, in the background, behind Guy, you can see the CFIS. He's right in the middle of sample run number 2. Everything's been going really well on that. And also on the left, well, it goes zooming in, but you can see we have the hatch open, and Dr. Bill has set up his doctor office and put the shingle up on the airlock.
Roger, we can see that, Dale, and we have a good picture of Guy right now. Dale, if you have a minute up, if you're up on the flight deck, are you there?
No, I'm up on the flight deck. Dale's on his way down. Richard just came up. He's off comm. He also wants a rocket contract. He grew an inch too.
Okay, Dan, if you could call up Spec 216 for us, we'd like to check something on our data and give us a readout of the backup self-test go, whether there's an asterisk or not.
Okay, Spec 216, just a second. Okay, what you're seeing now is Richard going sailing through the mid-deck, and Dale is getting ready to do his measurement. Okay, I got 216 up now. What did you want me to check?
A readout of the backup self-test go up in the upper left-hand corner, whether or not there is an asterisk, Dan.
Oh, yes, the self-test go, primary has an asterisk, and so does backup.
Roger, thank you very much, Dan. That's all we need.
Okay. Thanks for the help. That's about all I know about that system.
Boy, John, you're really digging deep when you ask the PLC to look at a PAM display.
Roger. It's a good picture of you, Dale.
Houston time.
Roger, Dale, you're not coming through real clearly. Say again.
Just asking what Houston time was, John.
Oh, it's 9:15 in the morning.
And there's a close-up of the patch for those of you that haven't seen it.
That STS-8 patch really looks good, Dale.
Now Dr. Bill's going to smile for you.
Right, he looks great.
I'll tell you what, you ought to see this mid-deck. You've ever seen before. Okay, watch Dr. Bill. He's heading into his office now. We get mad at him, we put him in there and close the head.
Roger, that's really super.
And here's the last member of our crew that you haven't seen so far. He's the one with the wild hair.
Oh, that looks good, Dan.
And he's showing you how he can eat a carrot. Hands upside down or something. There goes the carrot. The carrot just hit panel ML86B.
Okay, and Challenger Houston, we've gone ahead and switched the camera to the payload bay now.
Couldn't stand the us anymore, huh? Houston, we're going to get ready and power down the SCA at the end of the ASC thermal test. We're doing that now.
Roger that. We copy.
Are you on the elbow camera there now?
Roger. We're going to LOS here at Hawaii, and we're going to be handing over to the TDRS, and we don't have any TV at all now, Challenger.
Challenger Houston with you through TDRS. How do you copy?
We got you out clear.
Dale, Richard mentioned earlier that you had some questions about the RMS elbow dynamics. If now would be a good time for you, we're ready to listen to them.
Just a minute, let me get Richard on comm here because I think we both had some comments and some relate to what he saw in STS-2, so just give us about 20 seconds, Fish.
Roger.
Okay, and I powered off all the payload bay cameras and am shutting the system down.
Roger, we copy.
Guess you saw that we're having a good time up here today, Fish.
Looks like you guys are having a heck of a good time.
Things are really going well so far, too. No big surprise.
Yeah, Dale, everything looks real good down here, too. You're having a super mission.
Hey, Fish, hang with me.
Richard, you're a little broken. Why don't you give me another call here?
Okay, how about now? 1, 2, 3, 4, 5.
Okay, we have you loud and clear now. Go ahead.
Okay, the thing that I don't recall from STS-2 that I may have just forgotten is a hesitation in the elbow joint. Basically, first of all, I had forgotten about the fact that the drive switch has to be made very firmly to each the plus and the minus position, and so for a while we thought we weren't getting commands out, but actually it's a mechanical switch that's not like the simulator. But the thing that we saw that I didn't recall was the fact that when Dale was driving the elbow joint in course rate, it would drive for maybe 2 or 3 seconds, and then it would actually stop for a second or so, and then it would pick up and move again for 2 or 3 seconds, and then slow down and almost stop, and just like that as he moved it. And I think it might be a good idea if y'all looked at the data from the RMS checkout and just make sure that the joint movements, particularly the elbow, is to your liking.
Roger, Richard. We copy that, and as soon as we know something, we'll get back to you.
Okay, let me hand it over to Dale.
Okay, Fish, the only other thing I think I have is that, and I think this is nominal, or at least the simulator does it, one of the times when I selected the port on the RMS select switch, we got, besides the reach limit and the whatever else we get there, the singularity, we got a check CRT. It was a position encoder check on the wrist roll joint. I just did the on spec 94 at reset, and we pressed on. So I think that's nominal.
Challenger Houston, Dale, that was expected. What we would like to know is if this occurred in single joint only.
Well, you got me now, Fish. We were driving single joints during all that, so I'm probably 90% sure that's the case.
Okay, we're really referring to the elbow pauses that were mentioned. Was that noticed in the single joint only?
Well, elbow was the one that was most noticeable. I think we might have seen a little bit of it in shoulder pitch, but it certainly wasn't the dramatic start-stop that Richard described on the elbow pitch. And it was in single drive only.
Okay, Dale, we copy that. As soon as we know a little more, we'll get back to you, but much of that is an expected result up there.
Okay, we didn't do any driving in direct. We did do some in backup, but I don't think we really drove the elbow pitch joint enough in plus or minus to see the same effect that we saw in single.
Roger.
And we just got you probably saw, we just got a payload alert, a bus amps message, which is nominal. That's 5 minutes after powering down the SCA.
Roger, Dale. And Challenger Houston, when you're ready, we have some questions for you on the tail glow experiment that came up earlier.
Okay, stand by. We need to get Dan on here.
Roger.
What's your question?
Okay, Dan, when you talked about the aiming problem that you had with the camera, was this caused by the window mount position or by window cover interference?
Bill, you're breaking up. Start your question from scratch again, please.
Roger, in reference to the glow experiment, was the intensifier aiming problem caused by camera mount position or window cover interference? Challenger Houston, how do you copy?
Roger, got you loud and clear now?
Roger, Dan, did you copy my first question on the glow experiment?
No, it's fish. You cut out, and we haven't heard anything from you for about a minute or so, when you cut out just as you started talking.
Roger, we've had some intermittent uplink and downlink problems with TDRS. The question number one is, was your intensifier aiming problem that you talked about caused by the camera mount position or by interference with the window cover?
Well, I think it's a function of both. To tilt it up to get the picture you want, you stress it against the top of the hood that goes into the window, and in fact we had to rip it up from the bottom and put a couple layers of tape down to keep the light out, and that's partially caused by the fact that the camera mount, you can't drop it low enough. It doesn't go but about a half a degree or so below horizontal, and those two things combined, and that took up trying to get the light leaks patched and get a reasonable aim on the picture took up most of our paths. And, you can't do anything like, practice aiming it or anything until you can turn the intensifier on, which you can't do until you get into the dark.
Roger, Dan, we understand. In view of that, on page 3-2 of the Orbit Ops checklist, can you give me an idea of which photos you were able to obtain?
Okay, let me get that page out. I had it a second, but it floated away.
Roger, we'll stand by.
Fish, while he's doing that, where are we now? Are we coming up on South America?
You're a ways off. Looks like you're about 10 minutes off from the coast, right?
Okay, thank you.
Okay, Fish, on page Flight Supplement 3-2, we marched through the sequence where we just changed the shutter speed. Then we got down and we got the jet firings, but I think we got a little mixed up in there. But we made it all the way through the jet firings. And then by the time, we didn't have time to go back through them because we were coming in out of the window. So then we tried to go and get some of the shopping list, the star photos, which don't require the moon position, just darkness. And by the time we tried to get the camera aimed even higher, which was almost impossible, we were in the daylight, so we couldn't do anything, so we turned it off.
Roger, Dan, we copy.
And I think our next time we're going to do this, the actual tail glow one is on the extension day or day 6. So we're going to, in a free time, sit down and try and invent a better way of mounting that camera in the window and maybe do a little better.
Roger, Dan, we concur.
Okay, Fish, with reference to Cephas, we're in the collection mode on sample 2. We've inserted the collector, and the set voltage is 256. And we've got 81 minutes to go in the collect mode or block F.
Roger, Guy, we copy. And Challenger Houston, for Guy, I have a message for you on the Cephas.
Go ahead, Fish.
Yeah, in reference to the questions you had earlier about the sample pump forward indication after your full sample injection, it looks like that the beads within the syringe that act as sample stirrers may have interfered with plunger travel in your syringe, and that would have happened at the end of sample infusion. And we think what this may have done is prevented the operation of the limit switch. So what happens here is the pump motor continues in a forward mode. The mechanical clutch will stop the plunger motion during this time, but the motor will continue until auto reverse occurs, and the message you would get at that time would be the remove collector message. And we would expect that this situation may occur on all subsequent samples, but it should not affect nominal Cephas ops.
Fish, I only caught the last part of that. So you're saying we can essentially ignore that situation if it occurs on the remaining samples?
Roger, Dale. You can ignore that, and you might expect it to occur on your subsequent Cephas operations.
Okay, great. That's good news. We were worried something might be wrong there. Thanks a lot.
Roger, Dale.
Coming up on Africa somewhere. No, we got a few minutes of light, and I wish you would.
Challenger, Houston. Challenger, Houston. Challenger Houston with you through Botswana for 7 minutes. How copy?
Houston, loud and clear.
Roger, Richard, we have you loud and clear. And Challenger Houston, just to let you know, we see you in free drift down here. And when you're ready, I have a couple of quick messages to be done prior to sleep.
Yeah, stand by, Houston. Roger, Bill, I don't know explanation unless somebody just bumped the depth switch. We were in pulse mode. I guess what happened.
Roger, Richard.
Okay, Houston, go ahead with the messages.
Right, they're just two. Number one, we would like you to delete your supply water dump for this evening. And finally, we would like you to perform manual cabin atmosphere management, and specifically that will be the set caution and warning limits section of the Orbit Ops checklist, page 5-10.
Stan, you want us to delete the water dump and then do the manual cabin atmosphere management per 5-10?
Roger, Guy. Specifically, it's the block there entitled Set Caution and Warning Limits.
Right, we got it. Thank you.
And Challenger Houston, we show you in free drift again. Do you have an explanation for that?
Yeah, we just bumped the...
Okay, Houston, yeah, I guess what we discovered was the aft flight controller power was on, which I didn't realize. I thought we had turned it off, and I guess somebody had bumped the stick back here. But appreciate you telling us, because maybe that was it. I'm not sure.
Roger, Richard. We copy. Challenger Houston, we're 30 seconds LOS. See you at Indian Ocean in 1 minute.
Roger, Houston, see you there.
Display, Capcom.
Challenger Houston with you through Indian Ocean for 8 minutes.
Roger, Houston, loud and clear.
Roger, we have you loud and clear too.
And Houston, CDR.
Houston, go ahead, Richard.
Roger, Fish, I haven't had time today to make a really careful assessment to see if there was any tile damage during the ascent. We've briefly looked, and there's certainly nothing to be concerned about. There are two white tile on the right-hand OMS pod that have a dimple in them. Dan and I are looking at them. I would guess it's a surface dimple that's maybe a quarter of an inch deep. That the color is white throughout, and I guess the diameter is looks like ovals, really, maybe an inch high and an inch and a half wide. We've looked briefly around the windows up in the cabin, and there's one or two very minuscule chips of tile that have just chipped off. But essentially, what we can see is in great shape. And when we can either have time tomorrow to let you look at these OMS pods on TV or something, you can conclude for yourself the same thing, I think. And we'll be sure to take some pictures for a post-flight.
Roger, Richard. That sounds good to us.
But in summary, there's very close to zero damage at all. We did notice there is some smearing on the windows, and we'll try to document that. And as usual, we picked up some crud at SRB-SIP on all the front windows. But in general, no problems.
Roger, Richard. That's real good news.
Also, we've been able to see the ice crystals on the edge of the center engine. All day long, we've seen various chunks of, or not chunks, but pieces of ice come off at various times in flat formation with us for a while. The elevons have been, except for the left outboard, the elevons have been fairly close to fared all day. The left outboard seems to have drifted almost full up, or 3/4 up, I would say.
Hey, Roger, we copy that.
Okay. Also, Fish, we haven't had a whole lot of time except in just spurts to look out the window and take pictures, but we have, we saw the Great Dyke of Zimbabwe in between OMS 1 and OMS 2, and we've seen a number of ocean features, including eddies and internal waves, and taken a few pictures of those. And just generally a great time is being had by all.
Well, it sure looked like it on the TV pass. I wish I could be there with you.
You bet. Well, it is a lot of fun, and it's been a good day so far. And I'm getting ready to start this manual cabin atmosphere management if you want to get ECOM to keep me honest.
Hey, Roger, Richard, we'll watch it down here. Challenger Houston, we're 30 seconds LOS. We'll see you next at Guam at 9+08.
Roger.
This is Mission Control, Houston. Loss of signal at Indian Ocean Station, Guam, 20 minutes away, as the crew winds down in their first day in space, coming up on the sleep period, which begins some 2 hours from now. However, the pre-sleep activities, including the evening meal and all the other things that go with getting ready for bed. Dick Truly reported that some small indentions, what he calls dimples, roughly a quarter-inch deep and 1.5 inches, oval shape, are visible on the white tiles on the right-hand Ohms pod, and he sees one small chip on the tiles near the front cabin windows. During this just completed orbit, we heard a new call sign for the first time. One of the Capcoms, the crew referred to him as Fish, and that, of course, refers to Dr. Bill Fisher. This is his first time out as Capcom. He's backup Capcom on the Orbit 1 team. We'll return at Guam in 18 minutes at 8 hours 49 minutes elapsed time. Mission Control, Houston.
Challenger Houston with you through Guam for 1 minute, and we would like a GNC Spec 1 for variable parameters.
Okay, it'll be on 1.
Roger, Dan.
Richard's doing a co-Escal right now.
Roger, we copy. And Challenger Houston, we're about 15 seconds from probably losing you through a keyhole here if we don't talk to you just out of the keyhole. We'll see you in Hawaii in 8 minutes.
Okay, see you there.
And Challenger Houston, out of the keyhole for 40 more seconds through Guam.
Okay. And Houston, IMU line went very well. We have the numbers for you a little bit later when we get done with the co-Escal.
Roger, we copied, Dan. Good IMU line. And Challenger Houston, CRT-1 is yours.
Okay, thank you.
Challenger Houston, with you over Hawaii for 7 minutes. How copy?
Roger, Houston, read you loud and clear.
And we've got you loud and clear.
And Fish's CDR, I got one good mark. The Delta Bias, I think, was 0.15, but it's the authority with these pulse rate is so low that I'm afraid I'm just sitting here wasting gas. Just trying to maneuver the star.
Challenger Houston, Roger, Richard, we concur, and you can go ahead and stop the operations at this time.
Okay, I'm satisfied myself. It's obviously a doable job, but it's these depths, the authorities are just so low that the star tends to not respond, or the vehicle responds so slowly that it just takes many inputs. And it's about star set is about to happen anyway, so I think I'll just knock it off.
Roger, Richard, we copy that. Let us take a look at it and get back with you.
Okay, and would you like to have the IMU line data?
Richard, that's affirmed. You can go ahead and read it down.
I'm sorry, say again?
Roger, Richard. We would like the IMU aligned data, and we're ready to copy.
Okay, stars 29er and 22. Angle error was 0.02. The delta angles for IMU1 was minus 0.000. Delta Y plus 0.10. Delta Z minus 0.22. IMU2 minus 0.02 plus 0.01 minus 0.06. IMU3 plus 0.01 minus 0.01 minus 0.23. Execute time was 0 days, 9 hours, 0 minutes, and 57 seconds.
Roger, Richard. We copy. Challenger Houston, we'd like to get GNC Spec 1 and resume on Spec 60, please.
Roger, Houston, and GNC Spec 1 is on CRT 2.
Roger, we copy.
In Houston CDR, I stopped in the middle of the cabin atmosphere management procedure because the IMU line, I'm on page 5-10. I've set the C&W limits right up there at the top, and I'm getting ready to do the 14.7 cabin reg inlet stuff.
Roger, we copy, Richard, and CRT2 is yours.
Roger.
And Challenger Houston, we're about 45 seconds to Hawaii LOS, and we should be picking up TDRS.
Okay, see you there.
Challenger Houston, with you through TDRS, how copy? Challenger Houston, with you through TDRS, how copy? Challenger Houston, with you through TDRS, how copy?
Roger, Houston, read you loud and clear. How me?
We've got you loud and clear, Dan.
Okay, we heard you the first 2 times you called and answered, but apparently you weren't hearing us.
That's affirmed. We didn't have any response from you.
Okay, we do have a question for you, Fish. We've got a few fingerprints and bumped our heads on the windows, and it's got some greasy kid stuff smudges on them. And we're wondering if you remind us what the approved cleaning method for the interior windows is.
Stand by, Dan.
Okay.
Challenger Houston, Dan, you can go ahead and use alcohol wipes to clean them off.
Okay, fine.
Challenger Houston, I have a couple of questions for Dan. Challenger Houston, a couple of questions for Dan. Challenger Houston, I have a couple of questions for the PLT.
Houston, CDR.
This is Houston. Go ahead, Richard.
Roger, Fish. I was off the headset for a minute, and Dan said you were calling and was kind of staticky, and I was just wondering if we could help you.
Roger, I've got a couple of questions for Dan dealing with incubator status and heat pipe. And before I talk to him, maybe you can tell us if the weather we uplink got on board.
Yes, the weather message did get on board. I have not looked at it yet, but Dale said it looked good.
Okay.
And when Dan is able to get on here in a second, I'll get him here. Okay, Fish, I'm here. Go ahead.
Roger, Dan. I wonder if you could give us a little. Roger, Dan. I wonder if you could give us a little incubator status on. Tell us how things went and where you are in it.
Okay, let me see if I can find where I wrote the times down. Okay, I initiated auto sample starting at 7:27. I was a little bit late on that, I guess. We were doing some other things. Next, first sample at 7 plus 32. Houston Challenger, you copy?
Negative, Dan. I lost you after 7 plus 32. Challenger Houston, it appears we've lost our uplink temporarily. We'll give you a call in a few minutes when we've got it back. Challenger Houston, back with you through TDRS. How do you copy?
Roger, Houston, reading you loud and clear. How many?
Got you loud and clear, Richard. If we could have Dan just pick up, he'd given us 7 plus 32 on incubator activation times. If we could have him pick up from there.
Okay, I'm back again, and no, what I did, I activated starting at 7 plus 27 with the first sample in there, and went through, did all 4, and then turned around and got back and fixed the first sample at 7 plus 32. And then I have my timer set, or my tone set to alert me at 10 o'clock to do the second sample.
Roger, Dan, we copy. Also, could you comment on the status of the heat pipe, how it seems to have survived launch?
It survived fine. All the tape is on. It's looking good. I didn't get a chance to see it, but at one time when we came up and sunrise hit it, and Dale had commented that the bottom tape had turned brown. Like I said, I didn't get up and get a chance to see it. So, but other than that, generally every time I've looked at it, all the tapes have been black.
Roger, Dan. That's good news. And for the CDR, I've got a couple of quick questions.
Houston CDR, go ahead.
Roger, Richard. On the last COAS that you were doing, could you tell us a little bit about what DAPs you were in, and maybe give us a short summary of the activities you went through?
Okay, we were in A1B5 per the Orbit Ops checklist, and I tried. Well, let's see. First, we got the IMU alignment, and that was done, and then Dan and I identified the star, and it was a good ways away from the center of the COAS, like 4 degrees maybe almost, but it was positively identified, and I was in the ADAP, and I tried in vernier jets. I never tried the big jets because I didn't want to spin that gas, but I tried it both in pulse mode and even in discrete rate. I had intended to do it all in pulse. And the number of jet firings and the rates that were generated were just so slow that I felt like I was unnecessarily spinning the gas. I never went to the BDAP because it had even lower rates, as I recall.
Okay, Roger, we copy that, Richard. And one final question for you. If you have had a chance to get to that headset malfunction procedure that we sent up to you, we'd like to know the results.
Okay. No, I have not. I have the equipment out, and we haven't troubleshot it, but we will do it this evening before we go to bed, and be able to report to you. I've been ever since I got back on hardline comm. Since it's been working so well, I've stayed there, but I certainly am going to try to troubleshoot it because I'd like to be on wireless starting tomorrow morning.
Roger, we copy. Just to let you know that malfunction, that troubleshooting procedure is something you can do at your option, though.
Roger, understand. And Houston CDR, I'm about, at Guy's request, I'm about to do the flash evap deactivation for Cephas per this Q card, and the guy needs to talk to you about the Cephas, I think. Yeah, Fish, we finished up sample 2 and everything worked out well, and we got the tray back in the SSM, and we've closed down the unit for this evening, and we'll be back in operation again tomorrow.
Roger, Guy, that's good news. Challenger Houston, I have a Cephas question for Guy.
Go ahead, Fish.
Roger, Guy. At the bottom of your flight supplement, page 3-2, in the Q cards, on the Cephas Q cards, there are 2 times for sample 2 activation. Could you give them to us, please?
Yeah, hold on just a moment. Okay, what do you want again, Fish?
Roger, Guy, we're interested in the turn on and the turn off times for sample 2.
Okay, I started sample 2 at 6 hours and 58 minutes. And ended sample 2 at 9 hours and 43 minutes.
Roger, Guy, and also the original time you began running the Cephas.
Right, hold on just a moment. Okay, we've started at 1 hour and 30 minutes, right on time. Negative,
right.
sorry, man. 3 hours and a minute, Fish, sorry.
Roger, we copy 3 hours, 1 minute for your Cephas initiation.
That's affirmative.
Okay, Guy, thank you.
Houston, Challenger.
Houston, go ahead, Dan.
Yeah, Fish, I got a question for you now on the incubator. Would they prefer, since I got the initial initiation of the 4 samples started a little late, would they like me to slide each individual one an equal amount so I get the same delta time on them all?
Stand by, Dan. Challenger Houston. Dan, folks down here feel like you can leave them as they are. You don't need to slide them.
Okay, I'm getting ready to do number 2 then.
Roger.
Houston, CDR.
This is Houston. Go ahead, Richard.
Roger, a question on the manual cabin atmosphere procedure. I've the 14.7 cabin reg inlet number 2 valve is open. That's where I am in the procedure on 5-10. And the PPO2 is coming up, but oh so slowly. I'm assuming if we get to go to bedtime, we'll just go ahead and reclose that valve and stay in that configuration for the evening. Is that correct? Rather than take the chance of getting an alarm?
Roger, Richard. That's affirmed.
Okay. Well, I'll leave it in this configuration until our last pass of the evening, and if it hasn't tripped the limit, we'll just reclose it.
Roger.
And Fish, I just put the fixative in sample 2, and looked like quite a bit of it just oozed right back out through the septum there.
Roger, Dan. We copy that. Stand by. Challenger Houston. Dan, best suggestion we can make for you is to go ahead and clean up the stuff that oozed out of the septum there, and we will assume that enough fixative got in to do the job. So you should go ahead and press.
Roger, I figured that's what you'd say. I already did that. There's not a heck of a lot you can do, so I cleaned it up and I'm going to close it up now.
Roger, we copy, Dan. And Challenger Houston, just a note for you folks. Your state vector is on board and it's good for the next PLS on Rev 17. Your TIG will be 1 plus 00 plus 53. Challenger Houston.
Yes, sir. Go ahead.
Right, Richard, did you copy the state vector information I just sent up?
Yeah, I understand it's on board and good for overnight. I just happened to be in a position where I had 4 things and only 2 hands, and I couldn't get to acknowledge. Sorry.
Roger, and you copied the TIG time then of 10053?
No, I did not copy that, so you must have cut out. Say again.
Roger, TIG will be 1 plus 00 plus 53.
Okay, stand by.
Challenger Houston, we are 10 seconds LOS. See you at Indian Ocean at 10 plus 17.
Roger, Houston, thank you.
Challenger Houston with you through Indian Ocean for 4 minutes.
Roger, Houston, read you loud and clear.
We've got you loud and clear. Challenger Houston, we're 50 seconds LOS. Next AOS will be at Guam, 10 plus 41.
Roger, Houston, read you loud and clear.
Mission Control Houston, loss of signal through Indian Ocean Station. Final pass of the evening over that station. Guam in 18 minutes at 10:41 elapsed time. And this likely will be the final contact between Mission Control and the crew of Challenger before the crew goes into their sleep period. Some 8 hours scheduled for sleep. Challenger now the outset of orbit number 8. Returning in 17 minutes at Guam. Mission Control Houston, 10 hours, 24 minutes. This is Mission Control Houston. 50 seconds away from reacquisition at Guam Island Tracking Station.
I'm here.
We have Guam data now.
Challenger Houston with you through Guam for 5 minutes.
Roger, Houston, read you loud and clear. Hey, Fish, if you don't have anything for us, we're really loud and clear. The good doctor has a few words to pass.
Roger, Dan. We're looking forward to hearing from him.
He'll be with you in just a second.
Right, Dan, we were wondering if the doctor was in.
He's been in all day. I tell you, he's been working harder than anybody, Bill.
Well, it looked like he was working pretty hard on the TV.
Yeah, they drag him kicking and screaming up to the flight deck to talk to you, and now it's all dark out, so we're going to have to hold him up here until it comes daylight so he can see something.
Okay, and just to let you know, we are going to have a 30-second keyhole here, and if you lose me for a little bit, they'll be back for another 3.5 minutes.
Okay. Got the fish?
Right, but beware of the keyhole.
Okay, today we started out with the launch and entry. EOGs were routine on 2 subjects. We have
have done EOGs, and I apologize that I don't have the exact time, but we've done EOGs, 2 each, at approximately the end of the first pass. We did another at 0300. We did another at 0824. Did another one at 0841 start, 0850 end. We've gotten an evoke potential. We have heights. We've had continuous monitoring on EOG, blood pressure, and EKG on one subject. Physicals on everyone, and threshold audiometry. With any luck, we'll get a couple of others. We've also had complete urine sampling, and there have been a lot of odds and ends.
Roger, Bill. It sounds like you're gaining a tremendous amount of information and gathering all kinds of data. It really sounds like things are going well, and hope everything continues going that smoothly for you.
Things are going very well, and the most important part really is being here and not just the data we're getting.
Roger that, Bill. And Challenger Houston, just like to know if you folks have done the LIO changeout.
Oh, not yet, Houston. We want to say that just before bedtime.
Challenger Houston, we are 45 seconds LOS. Dan, I copied your last transmission on the LIO cartridge, and just a reminder for you to keep an eye on the cabin regs. And for Richard, every one of your COAS alignments has been within acceptable ranges. Just wanted to let you know that. So we're going LOS and see it.
That makes me feel better, and I'll have to work on the com at the next day.
Okay, Richard, if there's nothing else, you guys have a good night's sleep, and we'll see you tomorrow.
Roger, Fish. I didn't realize that this was our very last pass. We found that the alpha wall unit was bad. Over.
Roger, we copy the alpha wall unit was bad.
That's correct. That was a good troubleshooting procedure.
Okay, Richard, we will have Santiago if you need to talk to us, but unless we have something, we don't plan to call you back.
Okay, I tell you what, why don't you give us an AOS call there, but don't plan a whole bunch of mission notes, and we'll let you know where we are. We're going to go ahead and change out the LIO cartridge now. We don't mind you calling us. We're not going to be asleep.
Wilco, Richard.
Mission Control Houston. Loss of signal at Guam. Likely the final pass with any extensive communications for the evening. Mission Specialist 3, Dr. Bill Thornton, covered many of the measurements he had made on his fellow crewmates during the day: audiometry, EKG, blood pressure, height measurements, and weightlessness. And it sounded like he had a rather full day of patients. Santiago, Chile, the next station in 30 minutes. Also, Dick Truly discovered that the trouble with his wireless microphone had been in the wall unit, and he's changing that out. Perhaps that will correct the difficulty he has had with the wireless microphone. At 10 hours 50 minutes, this is Mission Control, Houston.
Challenger Houston, with you through Ascension UHF, only for 8 minutes.
Okay, Fish, we got you.
Okay, we've got you loud and clear. Sorry about the not calling you at Ago, but we had a little configuration problem.
Okay, understand. And Fish, you're breaking up here a little bit too. We understood what you said, but we had to fill in the words.
Dale, you got a pretty bad echo. Can you speak a little slower?
Fish, I was just saying that you're breaking up badly.
Roger, you were too, although I heard you on that last transmission clearly. How me?
Okay, that last one from you was clear also. Okay, and Fish, Dick just passed up that we've changed out the oil canister, and he just got through pitting the temperature controller to full hot.
Roger, Dale, we copy that. And Challenger Houston, on panel C3, we've got a switch for you.
Okay, Dick's right there. Go ahead.
Roger, we would like you to manually select lower right aft.
Okay.
Hey, Houston, we are on lower right aft, and when we got there, we got an antenna message.
Okay, Roger, we copy that, Richard. Challenger Houston.
Roger, Houston, go ahead.
Roger, Richard, sorry to be talking to you this late, but we're having some questions about our antenna, and we'd like to configure you to GSTAD and coverage prior to going LOS here. And if you could perform on page 2-2 of the orbit pocket checklist under the COM lost procedure, step number 3, beginning if stayed in coverage.
Okay, you want us to do just step 3 or all the way to the bottom?
Just step 3, Richard.
Okay, that did work, no problem.
Okay, and you guys have a good night.
Okay, and I'm heading back and we'll do step 3 right now.
Roger.
And Houston, where do you want, what position do you want the antenna switch on C3 left in?
Richard, we'd like you to go back to GPC on the antenna switch.
Something do what you want to do.
Roger. Well,
Challenger Houston, we're about 30 seconds LOS. Have a good night. You got a big day tomorrow.
yeah, see you in the morning. I don't see how it could have been more fun than today was. Boy, I don't know what that launch looked like from the ground, but it was spectacular from the cockpit.
It caught the attention of a few folks on the ground, too, Richard.
Sure was.
This is Mission Control, Houston. The handover of the flight control teams here in Mission Control is essentially complete, and the off-going flight director, Harold Drawn, will be expected to be available for his press conference in about a half an hour in room 135 of Building 2 here at the Johnson Space Center. Crew is in their scheduled sleep period, but they were quite active until recently, or at least through our last communication. There was some troubleshooting of a communications problem. Unsure at this time as to what the nature of that is, whether it's a configuration of antennas or some difficulty in relaying a signal through the TDRS to the spacecraft. Challenger is on orbit number 9. And the crew was expected to be getting to sleep fairly soon. They have the next big activity of the mission will be the deployment of the INSAT satellite, and that's only about 13 hours away. That'll be at approximately 1 day, 1 hour, 17 minutes, and 2 seconds mission elapsed time, predicted to be 2 seconds off of the published crew activity plan time. Spacecraft is in a 161 by 160 nautical mile orbit, taking an hour and a half to circle the Earth. Had a fairly busy day today, and they have completed the electrophoresis samples number 1 and 2. Some problem in positioning the camera used for the tail glow experiment. But all in all, everything has gone very well today. No major problems in work, and very few really even of the minor nature. We're at 12 hours and 2 minutes mission elapsed time. This is Mission Control, Houston.
4-5.
Challenger, Houston. Challenger, Houston, no reply required. We're going to switch NSPs. Challenger, Houston, no reply required. We're going to switch NSPs. Troubleshooting a comm problem.
Mission Control, Houston. 12 hours, 25 minutes mission elapsed time. During that last pass over the Guam station, the Capcom Brian O'Connor notified the crew that ground was commanding a change in the communication system, switching the network signal processors, and that is part of the troubleshooting activity going on relative to the communication system, and that required no action on the part of the crew. This is Mission Control, Houston. Things are very quiet here in Mission Control at the present time. Crew is in their scheduled sleep period and have about 4.5 hours remaining before they're due to get up and begin the activities before the deployment of the Indian National Satellite. That deployment will occur at about 1 day, 1 hour, and 17 minutes into the flight. The spacecraft is on the last remaining segment of orbit number 10, about to cross up over the midsection of South America. Very little going on. All systems on board the spacecraft appear to be in good shape at the present time. There have been no error messages on the fault chart for quite some time. And the flight controllers here in Mission Control simply preparing the teleprinter messages, which will be sent up in a couple of hours to the crew so that they will be ready for them to read at the start of their day. At 14 hours, 33 minutes into the flight of STS-8, this is Mission Control, Houston. Mission Control, Houston, at 15 hours, 37 minutes mission elapsed time. The flight of shuttle flight number 8. Challenger is currently out over the South Pacific. Crew is still in their scheduled sleep period, and things are relatively quiet here in Mission Control. principal activity has been to prepare the teleprinter messages to uplink to the crew, so they'll have them for their review early in the morning, describing any changes to the pre-flight published timeline. The crew faces a fairly busy day when they get up in about 3.5 hours after allowing them some time to prepare and consume their breakfast. They will be getting ready, first order of business, to deploy the Indian National Satellite. That is a communications and weather satellite for the government of India, the NSAT-1B, and it will be placed in geosynchronous orbit about 22,500 miles above the Indian continent. That activity begins right about 24 hours into the mission, and that's approximately 8 hours or so from this time, and that will begin with the checkout of the orbiter, all the systems on board the orbiter that support the deployment of that satellite, and then about 15 minutes later they will check the payload assist module and the INSAT satellite. At about 30 minutes after that, or about 1 day and 47 minutes into the flight, the pilot and commander, Richard Truly, will begin maneuvering the spacecraft to its deploy attitude, at which the satellite will be pointed in the right direction for its ejection from the cargo bay. This particular type of satellite is spin stabilized, well, most of those are, and it's very important that we do get those out. Well, a correction on that, the types we have flown in the past have been spin stabilized. This satellite is a 3-axis stabilized satellite. It is still, of course, very important the direction in which you point that, so that it is oriented properly for the firing of that payload assist module, a solid rocket motor. Again, that relates back the time of launch has been related to the time at which we deploy that satellite. It will go out of the payload bay so that it, at the proper time, is over the Indian continent at the equator, and so that it is oriented to have its guidance system lock in on both the sun and the earth to properly orient itself. Crew also, when their day begins, will at some point during the day activate the getaway special canisters number 346, 348, and 475. The 346 canister is an investigation into how cosmic rays in space will strike and interfere with computer circuits on the shuttle. These cosmic rays can impact the delicate electronic circuits and cause memory loss in some circuits. Experiment getaway special number 348 is a study of the erosion effects of atomic oxygen on carbon and osmium samples. And experiment number 475 is a repeat of the artificial snow experiment, which was initially flown on Shuttle Flight 6 by the Asahi Shimbun, which is a large Japanese newspaper in Tokyo. They have made some modifications to their experiment which did not work on STS-8 and hope to create snow in space and observe how the crystals form in a weightless environment. Additional samples on the continuous flow electrophoresis system will be run. Those will be 4 sets of samples that are scheduled to be run tomorrow, and that will represent the major portion of the activity for that experiment. Flight controllers here in Mission Control have been and are currently reviewing some of the television that came down from the spacecraft today. They saw a replay of the launch a little bit ago and are now reviewing the television from the orbiter middeck crew activities during the day. We are considering canceling the change of shift press conference for the off-going overnight planning team of flight controllers here in Mission Control. Really no significant activities tonight. Spacecraft systems have been operating quite well. The crew appears to be asleep, and everything is going quite smoothly at the present time. So when this team gets off shift, would have normally had 10 p.m. Central Daylight Time press conference. We are planning on canceling that unless other conditions should cause us to bring that back. If there should be any major problem, we would bring that back. We'll make a further announcement later on this evening as to whether we will hold that press conference. At 15 hours 43 minutes mission elapsed time, this is Mission Control, Houston. Mission Control, Houston, at 17 hours 35 minutes mission elapsed time. Mission Control is acquiring spacecraft data through the tracking data relay satellite. And there was an indication recently that not too long ago, one of the crew members turned on one of the CRTs, that is one of the 3 television screen displays in the cockpit, and that we don't have an indication of what the reason for that was at the present time. About an hour and 45 minutes ago, there was a fault message which simply says antenna. The communications officers are looking at why that message might have been generated. It's similar to 3 earlier messages that we got from the spacecraft data system earlier in the evening relating to the communication system problem. It appears that there was well, the problem that the ground controllers have been looking at seems to be one of low strength of signal or no signal coming into the antennas that are supposed to be receiving data through the tracking data relay satellite. They believe that involves a small electronics piece that decides which antenna is the appropriate one on the orbiter to be selected to receive the best signal from the satellite, at least in one of the redundant systems, one that had been being used. And they are continuing to think on that one and determine if that is indeed the probable cause there of those antenna messages getting on the fault summary chart. Everything else appears to be going well on board the spacecraft. Still in an approximately 160 nautical mile circular orbit. The Challenger is on the last portion of orbit number 12 out over the Pacific Ocean, just to the west of South America. And we'll be starting orbit number 13 in about 10 minutes or so. Teleprinter messages have been prepared to be uplinked to the crew, and those will be going up shortly, describing any changes in their flight activity plan for tomorrow. They have about an hour and 20 minutes remaining in their scheduled sleep period, and after they get up and have breakfast, they will begin making preparations for the deployment of the Indian National Satellite. And that will come at about 1 day, 1 hour and 17 minutes mission elapsed time, or about 8 hours from now, a little bit less. At 17 hours 38 minutes mission elapsed time, this is Mission Control, Houston. This is Mission Control, 18 minutes into the flight of STS-8. The Challenger on orbit number 13 has just passed into the range of the Dakar tracking station. The spacecraft has been within the view of the tracking data relay satellite, and we have had a constant stream of data from the vehicle since it got within range of that satellite. Its acquisition of signal as it comes around from the western Pacific region, picks up about 170 degrees west longitude. Data down from the spacecraft looks good. We see no new additional fault messages other than that the one at about 2 or more hours ago, on the antenna, which is again part of the communication system anomaly that flight controllers here have been looking at all evening. Again, it doesn't appear to be anything serious, but periodically get some indication that it looks like a piece of electronics gear that selects which of the antennas on board is the best one to receive signal. Does not always properly select the right one, and it will then give us a fault message from time to time. Spacecraft in a approximately 161 by 159 nautical mile orbit. Crew has about an hour left in their scheduled sleep period, and we're about an hour away from the beginning of handover to the next flight control team. That will be the Orbit 1 team with Flight Director Randy Stone. They will be working on the deployment of the Indian National Satellite. That deployment to take place in about 7 hours. At 18 hours, 3 minutes mission elapsed time, this is Mission Control, Houston. This is Mission Control. Once again, we wanted to indicate our intention to cancel the previously scheduled 10 p.m. change of shift briefing with off-going Flight Director Jay Green. The minimal activities here in Mission Control this evening on the planning team. We feel bear no cause to have a press conference this evening. However, should there be any events develop that need attention, we would always reserve the right to reinstitute that. But at the present time, things are very quiet, and we do intend to cancel that 10 p.m. change of shift press conference. There'll be further word on that a little later this evening. This is Mission Control.
Now that's the spirit.
Good morning, Challenger.
Good morning. How do you rate?
Got you loud and clear. How me?
Roger, loud and clear. That's the spirit.
Roger that. And we've got you TDRS right now. We're standing by for about 45 minutes.
Okie doke. We'll roust everybody up, and we're beginning to move.
Okay.
Mission Control. That was the Georgia Tech fight song for the alma mater Commander Richard Truly. Crew is up and getting to stir around on the spacecraft, Truly reports. Just got communication through the western edge of the range of the tracking data relay satellite. Data is good, and they're getting high data rate on S-band. And they're very pleased with that, the comm people are. It's 19 hours and 2 minutes into the 8th flight of the Space Shuttle. This is Mission Control.
Houston CDR.
Challenger Houston, go ahead.
Roger, Brian. I've taken a very quick once-over look at the morning mail and the teleprinter, and have just glanced at it, haven't reviewed it really, and I'm going to put it aside, and the guy's going to, we're beginning to clean up and shave and so forth, so I think I'll put off a few minutes really going through it in detail. If there's anything
that you need to get to me early this morning, now would be a good chance. Otherwise, we're just going to go ahead and about our business here and then organize the teleprinter message a little bit later.
Roger, we don't have anything immediate for you, Richard. We do have a comment about 2 of the messages. Messages 4 and 5 do not apply to today. They apply to flight day 5, but we want to get them up to you early, let you take a look at them.
The Star Tracker stuff, Roger, understand.
That's firm.
And incidentally, I'm communicating with you, listening over the speaker and using the wireless as a walkie-talkie. TK's idea. It seems to be working real well.
Well, that's great.
Mission Control, Houston. Crew of the Challenger is up and reviewing their teleprinter messages this morning. The handover now proceeding between the planning team, Flight Director Jay Green, and the Orbit 1 team of Randy Stone. And we will be starting the day's activities here shortly. Moving into the scheduled deployment of the Indian National Satellite at about 1 day, 1 hour and 17 minutes into the flight. That'll be occurring in about 5 hours or so. Everything looks very clean on board the Challenger. The flight controllers here in Mission Control who are participating in the handover, reporting to the oncoming shifts that in most cases, there are very few things that require any attention as they begin their new shift here. Just a reminder that we have canceled the previously scheduled 10 p.m. Central Daylight Time change of shift press conference that would have been with the off-going Flight Director Jay Green. We will not hold that unless between now and then, some great circumstance should change our minds, but we certainly intend to cancel that briefing. And as everything appears to be going smoothly at the present time, we don't anticipate rescheduling that. At 19 hours and 30 minutes into the flight of STS-8, this is Mission Control.
Challenger Houston, we're going off TDRS in about a minute. Pick you up in 5 minutes at IOS.
Roger, Houston. See you there.
Challenger Houston with you through IOS for about 8 minutes, and Orbit 1 team is on. Wishes you a good day.
Good morning, Houston, and we're looking forward to a good day, and we're doing our pre-sleep activities and getting squared away around here.
Okay, well, when you have some time out from your pre-sleep activities, we got a few notes for you. Nothing in a real hurry, so let us know when you want to talk about them.
Okay, it'll probably be a few minutes, and we'll give you a call.
Okay, talk to you then.
This is Shuttle Mission Control at 19 hours, 58 minutes, mission elapsed time. That communication occurred through Indian Ocean Station between Challenger Commander Dan Brandon's Stein and capsule communicator Jeff Hoffman. The vehicle's on orbit 14, and the crew reported its post-sleep activity in progress. The time bracketed for this activity and the summary timelines is notably longer than that reflected in past missions, since that time, that activity now encompasses such items as meal preparation, which were previously shredded out from post-sleep activity, but now that term embraces a variety of activities formerly listed separately. The Orbit 1 team under Flight Director Randy Stone has assumed control of the mission here in the Mission Control Center. The debriefing has been completed and was notably free of subjects, and the handover was the pleasant experience of not having too many problems to work as these two teams exchange console positions. Mission lapse time, 19 hours, 59 minutes. This is Mission Control, Houston.
Challenger Houston, 30 seconds LOS, talk to you through Yargity at 20+12.
Roger, Houston, read you loud and clear.
Challenger Houston's with you through Yargity for 8 minutes. Also loud and clear. Okay.
Houston, CDR ready to copy.
Okay, I got a bunch of Eclipse stuff for you first, and to start out with, Dick, we'd like a water supply dump at MET 21 hours, and we'd like you to dump tank Bravo to 0%, which should take approximately 1 hour.
Roger, understand. The supply water dump at 21 hours. Dump tank Bravo to 0%. It'll take an hour.
That's correct. We'd like you to reconfigure the cryo for set 1 and 2 operations. That'll be over on panel R1. The O2 and H2 cryo heaters for tank 3, Alpha and Bravo. 4 of them to off.
Okay, got him.
We don't need any cabin atmosphere management this morning, and down on panel MO10W, we'd like you to verify 2 14.7 cabin reg inlet valves closed. That's 2 valves closed.
Okay, I'm sure they are, but guys gonna double check right now.
Okay, and we're going to want to top off the supply water tanks, Charlie and Delta. That'll be panel R12, the supply water tanks Bravo inlet valve closed. Dick, did you copy the last on the supply tanks C and D?
No, we didn't.
Okay, Dan, we'd like you to top off supply water tanks Charlie and Delta on panel R12, supply water tank Bravo inlet valve to close, and the MOCR will call you when to reopen the valve when the tank C and D quantity gets up to about 95%. We estimate that'll be about 6 hours.
Okay, we'll go get that.
Okay, and finally, at 21 hours, you've got CFIS fixed sample 3 on the, excuse me, that's on the incubator, to fix sample 3. And since you had some minor seepage from the membrane on sample 2 when the syringe was injected, payloads would recommend that you inject sample 3 at a slightly slower injection rate to prevent a possible recurrence of that.
Jeff, do we need the deepest memory in order to do that?
Stand by on that.
Hey, Guy, Jeff, on that you just said you did mean CFIS and not incubator, right?
Negative, it's the incubator. We're talking about the incubator.
I thought it maybe sounded like, but you had said CFIS, so we just wanted to double check. Okay, I'll try and do it slower. I did it pretty slow last time, but we'll try even slower.
Okay, and we'll see how it works. Challenger, we're going LOS in about 30 seconds. It'll be a short one, pick you up in another minute through our oral.
Okay, Houston, we got tank Bravo inlet closed.
Copy. Copy. Challenger, Houston, we're LOS 30 seconds. Pick you up through Tidris in about 10 minutes.
Roger, Jeff, see you there.
Challenger, Houston's with you through Tidris.
Roger, Houston, reading you loud and clear, and I just fired up the fuel cell purge heaters.
Okay.
And Houston, CDR, diameter line's complete, and I'll give you the numbers in just a minute.
Okay, we're ready.
Jeff, are you hearing a bad squeal when I transmit?
Yes, we hear a pretty bad squeal. How are we coming through?
You're loud and clear. Let me change the batteries on this WCCU and get back to you.
Okay.
This shuttle mission control at 20 hours, 38 minutes mission elapsed time. We're communicating with the vehicle now through the Tidris system. Mission Commander Dick Truly still experiencing some trouble with his wireless communications unit. That squealing is indicative of something problematic with his unit exclusively. There have not been any feedback problems with any of the other 4 crew members. Commander Truly is changing the batteries in his wireless comm unit in the hope of alleviating that problem. Challenger on orbit 15.
Houston, Challenger, how do you read?
You sound a little bit better now, Dick.
Okay, Jeff, I've still got a squeal, so I guess that wasn't it, but I'm ready to reach the diameter data.
Okay, yeah, I guess I spoke prematurely when I said you sounded better, because the second time you talked, the squeal was just as bad as the first time.
Okay, Houston, this is a replacement for the CDR. Hopefully my comm's a little better. The IMU alignment, minus Y, star ID is number 20, minus Z is 51. Angle air was 0.01. Delta angles for 1 is delta X plus decimal 07. Y is minus decimal 03. Z is minus decimal 01. For number 2, it's minus decimal 11 plus decimal 03 minus decimal 02. For number 3, plus decimal 08 minus decimal 09er plus decimal 08. And the execution time was 20 hours, 33 minutes, and 48 seconds.
Okay, Dan, we copy all that. Ingo had a question. Are there any speakers on down there? We're trying to figure out whether it's a feedback coming into Dick's comm there.
Oh, we know the upstairs one isn't on, and I haven't been getting any feedback, but we can go down and check.
Okay.
Houston, CDR, that speaker was on, it's now off, and obviously I still have the squeal.
I'll confirm your squeal, that's for sure. Dick, the guys down here are going to think about that a little bit and see if we can come up with something for you to try.
Roger.
Houston, Challenger, are you still there?
We're with you.
Okay, while Inco's perplexing over Richard's WCCU, I'll just tell you what, with mine, every time I go down the mid-deck, I get a tremendous squeal into my ear, and I'm still using it. It works great on the flight deck, but for some reason on the mid-deck, it's pretty much useless, so I just take my headset off when I go down there, but it'll give us something to think about.
Okay, Inco's scratching his head about that.
Okay, that's probably all that's required. I can operate just fine the way it is.
Okay.
Houston, Challenger, how do you ring?
Very loud and very clear. Sounds good.
Roger, the problem is that these antennas are color-coded to match these leg devices, and the color code was incorrect, and so I am now matched up with an antenna that seems not to squeal with this leg unit.
Okay, well, I think you probably saved Inco a lot of trouble there trying to psych that out.
Okay, to tell you the honest truth, I'm still not satisfied with it, because even though that I do not have the squeal, I do have in my own side tone a continual squelch that's kind of irritating. So later on in the day, I'm going to try another unit if I can, but right now at least it's loud and clear for you, so I can operate this way just fine.
Okay, that sounds good. Challenger Houston, we've switched from Tidris over to Mila.
Okay, Houston, read your loud and clear through Mila. And Houston, Challenger, I'm starting the manual fuel cell purge right now.
Okay, Dan.
Houston, Challenger.
Go ahead.
Two things. I'm on fuel cell number 2 on the purge. The O2 flow came up as expected, and the H2 flow is the one we have that problem with, so I have no visibility into that. I'm assuming that one's working all right. And the other is that the PPO2 sensor just tripped as a result of our manual management procedure.
Okay, we saw the PPO2 alarm. We think it's an instrumentation problem, and right now you should ignore it.
Okay, we will.
Challenger, we're 30 seconds LOS. Pick you up at Dakar at 2112.
Okay, we'll see you there.
Challenger Houston with you through Dakar for about 7 minutes, and Dan, we got a couple of questions on the PCS.
Hey, Houston, Challenger. Jeff, if there's not a big crush on that PCS, Rich is trying to get his comm squared away, and he'd like to be up on when we talk about it.
Sure, Dan, we can wait on that. We got about a 7-minute pass here.
Okay, fine. He should be with us in a second.
We'll stand by.
Okay.
Okay, I'm sure he'll give you a call as soon as he gets up. If not, I'll tag up before you go off.
Challenger Houston, we've got 3 minutes left in the pass.
Okay, let me check on the comm situation here. Houston, Challenger, how do you read?
Read you loud and clear.
Well, I read you loud and clear for the first time in a long time also. Go ahead.
Okay, what we'd like to find out is whether anybody was doing anything to the PCS at the time of the alarm. We had been assuming that there was going to be no manual management of the PCS, and therefore when we saw sensors changing around at various times, we assumed an instrumentation problem. But we'd like your confirmation on that.
That's firm, Jim. The only stand by. Roger, Jeff. Negative. We have not done the manual management procedure this morning because you called up and deleted it. The only thing that we have done this morning was we closed the 14.7 cabin reg inlet, which apparently I should have closed pre-sleep last night. On board, the indication is that PPO2 sensors Alpha and Charlie both agree and read about 3.2, but Bravo for some reason crept up to above 3.4. So other than closing that one valve this morning, that's the only thing I've done with it.
Okay, we understand. We're about 30 seconds LOS. We've got iOS pass at 21:31. You've got a Timbu on board now for your deploy ID and the time. And I've got a preliminary deploy pad, which I'll read to you anytime you want to get it in the subsequent passes.
Okay, we'll be ready to copy as soon as you come up again, Jeff. Thanks a lot.
Okay, talk to you through iOS.
It's Shuttle Mission Control at 21 hours, 19 minutes, mission elapsed time, activity on board the vehicle, and communications now beginning to pick up as we come out of the post-sleep activity period and begin the day's events. The PCS alarm was a tone we got in the primary coolant system. May have been a spurious alarm, and the flight control team was just checking with crew activities to see if there were any actions on board Challenger which may have prompted that alarm. The Timbu that capsule communicator Jeff Hoffman referred to as a table maintenance buffer update, which is uplinked to the onboard computers to prevent alarms from being triggered by temperatures in the APU system, in as much as there was earlier reported a circuit pump failure in the APU hydraulic system. That failure is going to cause temperature spikes, and in as much as we're aware of the problem with that system, why there's no need to have alarms constantly flag us as those temperatures fluctuate. Accordingly, the temperature alarm levels will be adjusted by that table maintenance buffer update. The new pad for deploy time will be a deployment time for INSAT expected to be at 1 day, 1 hour, 16 minutes, and 54
Challenger
seconds.
Houston, due to the wonders of Tidris, it looks like we don't have to wait until iOS to talk to you.
During the next
so
acquisition
if you'd like
of signal
a
through
preliminary
the
deploy
Ocean
pad, I
Station
can read it up to you
in
anytime.
about 9.5 minutes from now. Primary activities for the day's event are, of course, the deployment of INSAT at the time I just cited to you. And
Roger,
of course,
Houston, we copy that, and we're digging out the PAM deploy checklist right now, and as soon as we get them up and settled in, we'll ask you for them.
Okay, I'll wait on you.
this mission control again at that air-to-ground exchange through the teeter. It's shuttle mission control at 21 hours 19 minutes mission elapsed time. Activity on board the vehicle and communications now beginning to pick up as we come out of the post-sleep activity period and begin the day's events. The PCS alarm was a tone we got in the primary coolant system. May have been a spurious alarm, and the flight control team was just checking with crew activities to see if there were any actions on board Challenger which may have prompted that alarm. The Timbu that capsule communicator Jeff Hoffman referred to as the table maintenance buffer update, which is uplinked to the onboard computers to prevent alarms from being triggered by temperatures in the APU system, in as much as there was earlier reported a circuit pump failure in the APU hydraulic system. That failure is going to cause temperature spikes, and in as much as we're aware of the problem with that system, why there's no need to have alarms constantly flag us as those temperatures fluctuate. Accordingly, the temperature alarm levels will be adjusted by that table maintenance buffer update. The new pad for deploy time will be a deployment time for INSAT expected to be at 1 day, 1 hour, 16 minutes, and 54 seconds.
Houston, due to the wonders of TDRS, it looks like we don't have to wait until iOS to talk to you.
During the next acquisition
so if you'd like
signal
a
through
preliminary
the
deploy
ocean
pad, I
station
can read it up to you anytime.
in about 9.5 minutes from now. Primary activities for the day's event are, of course, the deployment of INSAT at the time I just cited to you. And
Roger,
of course,
Houston, we copy that. We're digging out the PAM deploy checklist right now, and as soon as we get them up and settled in, we'll ask you for them.
Okay, I'll wait on you.
this mission control again, that air-to-ground exchange through the TDRS system. And continuing, the other major event of the day is the scheduled CFIS activities where the final samples will be processed through the continuous flow electrophoresis machine. Today will represent the end of CFIS activities for this mission. And a number of medical DSOs, or detailed secondary objectives, will be performed on the crew members by Dr. Bill Thornton. At mission elapse time, 21 days, 21 hours, 23 minutes. This is Mission Control Houston.
Houston Challenger, I think we're finally ready to copy the deploy pad, so go ahead anytime.
Okay. Your MET is 001/01:16:54. The GMT is 243/07:48:54. And item 17 on the table is +21023,334. Deploy attitude, roll 344.98, pitch 072.79, yaw 335.24. Read back.
Okay, and I'm assuming you don't have you're going to wait later to pass us a step pad, is that correct?
That's firm, yeah. We'll get that to you later.
Oh, okay, Jeff, thanks a lot. And Jeff, while I got you here,
Let me update INCO on the WCCU situation just so he's up to speed with us and we can work it from here.
Okay, we're listening.
Okay, first of all, the Alpha unit failed yesterday, and in order to replace it, I got out one of the Echo units and was attempting to use that. Unbeknownst to me, a configuration had been set up downstairs that also had used an Echo unit, and I think the interference that I've been having to squeal has been an improper configuration on board due to that. I am now using the Delta unit at the CDR station, and it seems to be working okay. And when Dale has a chance downstairs, he's going to plug both of the Echo units into the splitter. And I think we should be back into good configuration with the exception of the failure yesterday of the Alpha unit.
Okay, we understand what you've said, and we're about 20 seconds LOS. This time we really will get you at IOS at 21:31, which is about 2 minutes.
Okie doke, we'll see you there.
And Houston, the water dump for Tank Bravo just started.
Okay, Dan. Challenger, Houston back with you through IOS, about 9 minutes.
Roger, you're on clear, Houston.
Challenger, Houston, on the overhead panels.
Roger, go ahead.
We need the RJD drivers, 8 of them on for the primaries.
Roger, stand by. Roger, Houston, the primary drivers are on.
Yeah, that step got buried in the interconnect step on the post-sleep activity, and we asked you not to do the interconnect. That's probably what happened.
Exactly what happened. You read our mind. Houston Challenger, we're just getting ready to do the cryo O2 tank heater sensor check, so if you see something going on, that's it.
Okay, thanks for letting us know.
And Houston CDR, the test worked okay on the O2 tank heater sensor test. We did get a message when I reset tank 2 and looking at the Spec 68, it looked like one of the sensors just didn't reset, was a little slower to reset than the others, and perhaps that explains it, but the test looks okay to us.
Could you verify that you said one sensor was slower to reset, or it did not reset at all?
It did reset, but on the CRT, it was looked like 1 or 2 updates on the CRT before it reset. It was Cryo Tank 2. If you'd like me to go through it again, I will.
No, that's okay. We've got it. One thing you ought to know, we see stratification in O2 Tank 3, and we're currently about 60 PSI away from the SM limit. It may be that when you're LOS, you might get a alarm on that. If so, it's just the stratification. And that was O2 Tank 3.
Okay, O2 Tank 3, and if we do get alarm, you're saying we can just note what it is, but then ignore it.
That's correct.
And Houston Challenger, before the flight, ECOM was requesting some pictures of the supply water dump, if we got anything, and I haven't been taking any pictures because we've been dumping and I haven't seen anything unusual back there.
Okay, I guess nothing to do but keep your eyes on it.
Houston Challenger.
Go ahead. Go ahead.
Roger, the people on the middeck had me look out the side hatch, and it looks like a snowstorm, so I'll go down and try and get a picture of it for them.
Eternal vigilance. That's what you need.
Must be.
Challenger, we're going LOS 30 seconds. Talk to you again through Yargity at 2147.
Roger, Houston, see you there.
Challenger, this is Houston with you through Yargity for 8 minutes.
Roger, Houston. Line clear. Hi, Mary. How you doing?
Fine, thanks. Dick, how are you?
Shoot, we've never had so much fun in our life.
I believe that.
And Houston, CDR.
Go ahead, Dick.
Roger, just thought we'd bring you up to date. We think we're pretty much up to speed. The one thing we have not gotten around to doing this morning is taking a look at the cabin fan filter, and Dan and I are going to do that here. It's been a little bit busy downstairs with us trying to set up cameras and so forth ahead of time for the deploy, but we'll get to that. Other than that, I think we've done everything that we know of that's in the checklist.
We concur with that. You look good to us, Dick.
Okay. And Houston, CDR.
Go ahead. Go ahead, CDR.
Roger, while we had a second here, I thought I'd let you know that during the evening last night, Dan and I waked up for a rev or so in the middle of the night, and the thing that woke me wide awake was I looked out the top window and saw two active volcanoes on, and the time was about 15:29 MET. I'm fairly certain it was in the vicinity of New Guinea, and it was the middle of the night and all the other guys were sleeping, and so I did not photograph those. However, later on while we were up, we did get a lot of photography or a lot of observations of the South Pacific and of the South Pacific Islands, and also we think we got a couple of pictures of Henderson Island.
That must be really fine to be able to see those things from up there.
Unbelievable. We also got our first look at the northern portion of the Great Barrier Reef, although again we took a couple of pictures that I just couldn't stand not to take, but we didn't take a lot because we didn't want to wake folks up.
One note which we did have, I just remind you about with volcanoes is to look around for any discolored water in the vicinity and photograph that if possible.
Roger that.
Challenger, Houston, in about 30 seconds we'll have a minute break between Yargity and Auroral. Challenger, Houston, back with you through Auroral for 3 minutes.
Roger, Houston, and we think we're looking straight down at the Great Sandy Desert of Australia. Whatever it is beautiful, and we're taking a couple of pictures.
I spent some time there myself. It is beautiful. Challenger, we're LOS in 30 seconds. Pick you up through Tidris at 2212. Challenger, Houston's with you through Tidris. Challenger, Houston, we see tank Bravo and water at 0%, so it's okay to stop the water dump anytime.
Roger. Houston, CDR.
Go ahead. Go ahead, Dick.
We're getting ready to clean the cabin fan filter real quick, and the cabin fan is going to go off momentarily, and so that's the reason why.
Okay. Thanks for the warning.
It's Mission Control Houston, 22 hours, 25 minutes, mission elapsed time on that advisory by Mission Commander Dick Truly as a courtesy to the flight control team to warn them ahead of time that the cabin fan was going to be inactivated while they cleaned some filters. Of course, if the control team had...
And Jeff, MS1, what site would you like this PAM ASC thermal test over?
Stand by. We're thinking about doing it over Mila. We'll start the Mila pass at 2232, and we'll give you a call when we're configured to get the data.
Okay, we'll have the ST-8 powered up, and Guy will be standing by to do the item 1.
Okay, that's good.
This is Mission Control Houston again, continuing that advisory by Dick Truly as a courtesy to the flight control team. Since if the flight controllers had observed that cabin fan spontaneously stopping without any warning, why it would have been the source for some rather extreme concern here in the control center. Mission Specialist Dale Gardner asking the control team's preference for a site over which to perform check out of the airborne support equipment of the payload assist module. That will be represent the leading edge of deployment preparations this morning. The thermal testing to be performed on the checklist by Mission Specialist Guy Bluford. And Mission Specialist Dale Gardner will be doing some TV setup in preparation to make a videotape record of that deployment sequence. And determination will be to have that thermal check of the airborne support equipment performed as we overfly Mila, so that the flight control team here and the payload operations control center and the INSAT satellite control center at Hassan can watch that data. Mission elapsed time 22 hours, 28 minutes. This is Mission Control Houston.
Challenger Houston's with you through the States.
Roger, Houston, and the cabin fan is back up. The filter was not terribly dirty, but it was, with the trouble it took to get to it, Dr. Bill had his EOG chair taped to the floor right on top of it, so since we took the trouble to undo all that, we went ahead and cleaned it anyway.
Okay. Challenger Houston, we're going LOS in 20 seconds. In about 2 minutes, we'll pick you up again at Mila.
We'll be ready for the PAM check.
And we'll give you a call on that. Challenger Houston's got you through Mila, and we're ready for the test.
Roger, Houston, and we're going item 1 now.
It's Mission Control Houston at 22 hours, 34 minutes. The data now being looked at here in the control center on the downlink of this payload assist module heat test, thermal test. And the payloads officer, Mike Brecky, indicating that all the temperatures being observed are within normal ranges, and data verifies that the PAM will be within thermal tolerances for deployment.
Challenger Houston, we've got all the data we need from the SCA, so you can go ahead and terminate the test if you like.
Roger, copy.
Challenger Houston, we're going LOS now. Lose you for about 3 minutes, pick you up at Dakar 2247. Challenger Houston with you through Dakar for 9 minutes.
Loud and clear, Jeff. Roger, Houston, Challenger reaching loud and clear.
Okay, and we read you fine. Challenger Houston, we're going to be uplinking you a state vector momentarily.
Roger, Jeff.
Challenger Houston, we've switched over to Tidris.
Roger.
Challenger, Houston, 30 seconds LOS, pick you up through iOS 2308.
Okay, Roger, Houston.
This Mission Control Houston at 23 hours, 6 minutes into the flight of STS-8. It's fairly quiet on board the vehicle with not a lot of air-to-ground transmission as the crew's involved in a variety of activities. Commander Dick Truly's performing some medical DSOs, detailed secondary objectives with Dr. Bill Thornton in the middeck of the vehicle, one of those being the visual acuity test where some measurements are made of focusing ability using a target pasted to the wall of the middeck. Pilot Dan Brandenstein is setting up some 16mm cameras out the port windows. I'm sorry, out the aft windows of the aft flight deck to document the PAM deployment sequence later this morning. Mission Specialist Dale Gardner is similarly setting up TV cameras for some downlink video, which we'll be getting, illustrating some of the INSAT checkout procedures. The deployment will not be downlink live, but we'll acquire videotape of that event and downplay it, downlink it later in the mission this morning for replay around 3 o'clock Central Time. And Mission Specialist Guy Bluford has been performing the thermal tests of the payload assist module. All those temperatures were within normal constraints, ranging at various locations on the PAM from 66 to 78 degrees Fahrenheit. And all of those were certainly within acceptable limits. Guy Bluford will be loading the pulse code modulator master unit with some orbit operations software. And soon the crew will dedicate itself to a review of deployment procedures in advance of entering the deployment and checkout activities prior to the PAM deployment. And we are now AOS through Indian Ocean Station at 23 hours, 9 minutes. This is Shuttle Mission Control.
Challenger Houston's with you through iOS for 5 minutes.
Roger, Houston, reading you loud and clear. We're hard at taking Earth resources photos right now, or part of the crew is.
We're getting some good shots of site number 5. And Jeff, how do you read MS1? I'm on one of these E-duplex units right now. I gave Richard the D unit I was on yesterday. How do you copy me?
I can understand what you say pretty well. There's I guess a marginal bit of echo in there, but you're pretty readable.
Okay, well, I'll stay on this one then for the deploy.
That sounded much better, the second one. Dale, I don't want to confuse you on that. I thought you had changed between your first call and your second call. It turns out we had changed our reception. You sound real good now.
Okay, thanks, Jeff.
Challenger, we're 30 seconds LOS. Talk to you through Yargity in 10 minutes at 23:23.
Roger, see you there. Okay, we're just getting sites 6 Alpha, Jeff.
Okay, hope you're getting some good pictures.
It's mission control at 23 hours, 15 minutes, mission elapsed time. The FIDO, Flight Dynamics Officer Brian Jones, has just reported to Flight Director Randy Stone that the preliminary deploy pad issued earlier will be unchanged and will in fact be the actual deploy time. So the expected deploy time for INSAT will be 1 day, 1 hour, 16 minutes, 54 seconds mission elapsed time. We're currently LOS will acquire again in about 7 minutes through Yargity. This is Mission Control Houston.
Challenger Houston with you through Yargity for 8 minutes.
Well, Jeff, we're all ready to deploy a PAM. How are the lines between the States and Hassan looking?
Payloads tells us the voice and the data lines are looking good. And we can also tell you at this time that no update will be necessary for the deploy pad, which I read you earlier.
Good news.
Challenger, would you like a SEP pad now or at Hawaii?
Why don't you stand by, wait from the seat for a few minutes. We'll be right back.
Sure, we have about 5 minutes left here, then there's a 20-minute LOS, and then we'll get you at Hawaii.
Yeah, hold on, he's getting in position. Okay, Jeff, we have 3 books out with 3 pencil toys over them. Go ahead.
Boy, I don't know if I can, that's 3-1 against me, but here goes. You're both ohms. TV roll is 180. Trim is plus 0.2 minus 5.7 plus 5.7. Weight 219602. Your TIG is 1 day /01 : 31 : 54.0. Your PEG 7 target is plus 0010.6. All balls minus 003.0. Your burn attitude 336.049.015. Delta V total 0011.0. TGO 00:06. VGO X plus 0010.61. Y all balls Z plus 002.97. Targeted apogee 167. Targeted perigee plus 159er. And the helium press vapor isols Alpha open, Bravo closed. Readback.
Okay, it's both ohms, 180 plus 0.2 minus 5.7 plus 5.7. 219602, 1013154.0 plus 10.6 all balls minus 3.0. 36049er 015 11.0 :06 plus 10.61 all balls plus 2.97. 167 plus 159er. Alpha open, Bravo close.
Readback is all correct, except we had some static when you gave us the burn attitude roll. Could you repeat that, please?
Roger.
looks like we got cut out again. Could you let us have the burn attitude roll, please?
Okay, 336.
Third time lucky. Readback is correct.
Okay.
Challenger, we're 30 seconds LOS. We'll lose you for about 20 minutes and pick you up at Hawaii at 23:51.
Roger, Houston.
This is Mission Control Houston at 23 hours, 32 minutes mission elapsed time. We have a LOS period of about 20 minutes now before we reacquire through Hawaii on orbit 17. Challenger right now over the heart of Australia. And the crew is presently reviewing its deploy procedures. The crew station assignments for pre-deploy through deploy are to be as follows. Mission Commander Dick Truly will be at the aft starboard station, the maneuver station. Pilot Dan Brandenstein will be in the forward right seat. Mission Specialist Dale Gardner will be in the forward left seat, normally the commander's seat. And Mission Specialist Guy Bluford will be at the aft crew station at the port or payload station. In preparation for the OMS separation maneuver, the Commander Dick Truly and Mission Specialist Dale Gardner will exchange positions. Truly will get into the commander's seat, and Dale Gardner will go to the aft starboard station. During that most recent pass, Capcom Jeff Hoffman advised the crew of a TIG, or ignition time, for the separation burn. Let me repeat all those numbers here. The deploy time for INSAT is to be 1 day, 1 hour, 16 minutes, 54 seconds. Time of ignition for the OMS separation burn is scheduled for 1 day, 1 hour, 31 minutes, 54 seconds. At mission elapsed time, 23 hours, 34 minutes. This is Mission Control Houston.
Challenger Houston with you through Hawaii for 4 minutes.
Roger, Houston, read you loud and clear.
In a little while, we'll have some Peg 7 targets coming up to you.
Okie doke.
Challenger Houston, we're about 20 seconds LOS. Talk to you through Buckhorn in 5 minutes at 00.
Roger, Jeff. We'll see you at Buckhorn.
And we're going to be looking for the PCM to be loaded with the deploy specs.
Roger, you bet.
Challenger Houston with you through Buckhorn.
Loud and clear, you should have one.
Okay, we confirm that, thanks.
This Mission Control Houston, STS-8, is now in its second day. Mission elapsed time, 1 day, 0 hours, 0 minutes. This Mission Control Houston standing by for downlink TV, and we're waiting for the crew to configure the elbow camera for the best views of the pre-deploy checkout.
Challenger Houston.
Yeah, Houston.
We're all set up to receive some TV here. INCO would like you to configure the elbow camera.
Okay. We have it all aimed already. I did that previously, Jeff.
Okay, that sounds good.
You want to do it here, you say, at Buckhorn?
Well, we're over Goldstone, yeah, and Goldstone's configured for TV.
I need to get some payload bay lights on for you then. Stand by.
Mission Control Houston, 1 day, 0 hours, 3 minutes, so we'll have TV momentarily. Mission Specialist Dale Gardner at the aft crew station.
Okay, Challenger, we see a picture coming down from inside the cabin. Looks like you guys are all in full control there.
Just waiting for the lights to come up a little brighter and I'll give you the elbow, Jeff.
Okay, looking forward to seeing it.
Okay, there you go. You're seeing by the edge of the PFTA and just seeing the port side of the movable part of the sun shield and a little bit of the port side of the stationary part of the sun shield.
Looks like a strange bit of modern architecture.
It does get some. You gotta get used to it looking at it at this angle.
Both of them are in there, working hard. No rest for the weary.
Mission Control Houston, brief keyhole here in TV coverage.
Camera Delta view.
And we'll pick up again through.
We're handing over. Right now we're seeing some vertical color bars, which I assume is not what you guys are doing up there.
Okay. And Houston CDR, you can check our depth. Should be A1 and B4. We're
Stand by. Okay, Inco's ready for that. We're watching the gimbal check. Dick?
SCA power is coming on now.
Okay, Dale, and we have a picture back. And did you copy that we're ready for the gimbal check?
okay. Stand by. We'll be going to OPS 8 momentarily. 202 momentarily.
Ignore the message, Jeff. It's from our port mode.
Okay, we're following you, Dale.
Here's the port mode going back. Backup SCA looks okay.
And the secondary gimbal check looked good on board. Primaries in progress.
Mission Control Houston, we're looking at Mission Specialist Colonel Guy Bluford. In the center of the screen, Commander Dick Truly. To the left, and at the left of the screen, Pilot Dan Brandenstein. Gimbal check's being performed now to verify the flight control worthiness of the INSAT payload.
Okay, Houston, both gimbal checks look good on board. The targets look good. We fixed up the weight. We're ready to go back to 201.
Okay, Dick, we've been watching from down here, and everything looks good to us with the gimbals.
Okay.
And Jeff, guys, on the bottom of page 3-6.
Okay, we're watching.
Mission Control Houston, looking at the aft crew station once again. You can see Mission Specialist Dale Gardner to the right of the screen. We're standing by for views of opening of the sun shield, which shall occur momentarily.
Okay, we're going to 3-7A, INSAT activation.
We're with you.
This portion of the verification intended to affirm the satellite's capability to receive and transmit signals.
Okay, Houston, here we go with opening the sun shield.
We're watching.
Movement.
This view being provided by the shoulder camera, elbow camera on the remote manipulator system, and is sort of a side look at the payload bay.
Movement stop.
Sun shield now opened.
like we got two micro switches indicating open.
We confirm it. That's what we see down here. Looks like you've moved out of range of Mila and we've lost the picture. We're still with you through Bermuda for another 3 minutes.
Understand, Houston, and we're putting external power on the inside right now.
Okay, we're watching the data down here.
This Mission Control Houston, we're now less than an hour away from scheduled deploy of INSAT. Mission elapsed time is 1 day, 0 hours, 17 minutes.
Well, Jeff, guys doing good work today. The satellite's on and we're flowing data.
Sounds good. Challenger, we're 30 seconds LOS. Speak to you through Dakar in about 4 minutes at 0:23.
Roger, understand, Houston, we've just turned the batteries on, and the TWTs have just come on.
Shuttle Mission Control, at this point in the payload checkout procedure, virtually all the activities are performed by the crew on board, with the Mission Control Team and the Payloads Operations Center here in Houston, as well as the INSAT Satellite Control Facility in Hassan, India, are monitoring those checkouts. Preparatory to cargo injection, the orbiter flight crew verifies the spacecraft through a series of checks before they configure that payload for deployment. Satellite will be spun up to a rate of about 40 RPM, 40 revolutions per minute is nominal, but anything between 36 and 44 RPM is acceptable. Communications and other subsystems will be checked by means of an electrical and communications harness to the flight crew cabin. Payload ordnance items will then be armed, and all the checks are performed remotely from the flight crew cabin. Payload data are transmitted from the orbiter to the Mission Control Center here in Houston for analysis and verification. And in about 10 minutes from now, the Mission Control Team and Payload Operations Center will verify the validity of that data and give the crew a go or no-go for deploy. That deploy would occur nominally in about 55 minutes from now. There'll be a final pre-injection sequence that lasts about 30 minutes. The orbiter will be maneuvered into a deployment attitude. The payload bay will be facing facing away from the surface of the Earth. The bottom of the Space Shuttle will be toward Earth, and the nose of the orbiter will be facing the velocity vector. We're just about a minute and a half away from acquisition of signal through Dakar at 1 day, 0 hours, 22 minutes. This is Mission Control Houston. This is Mission Control Houston. Payloads Officer Rob Kelso has reported to the Flight Director, Randy Stone, that he has been advised by the Satellite Control Facility in Hassan that they got a good stream of data during that test, that most recent test, and we'll be looking for transmitters on when we acquire at Dakar.
Challenger Houston with you through Dakar for 8 minutes.
Roger, Houston, we got clear, and we got the transmitters on, and the satellite still looks good.
Good news.
This is Mission Control Houston. In about 5 minutes, NASA Select will feature playback of the INSAT pre-deploy video. and we are standing by for some good news to uplink to the vehicle about a go for deployment.
Challenger Houston, at this time, the PAM, the INSAT, and the ground network are all go.
Understand, Houston, copy. We're go for deploy.
You are go.
Roger, Houston. Thanks a lot. That's good news. Okay, Jeff, we got a little light in the bay now, and I can see the satellite a little more clearly. The C-band antenna, which is on top, looks in good shape. I can see the VHRR cooler over on the port side. It looks to be in good shape, and I can see the solar array hinge points on the forward and over on the starboard side. Everything looks in good shape. Satellite looks fine.
Well, we'll enjoy that vicariously through your words. Thanks.
This Mission Control Houston, the crew given a go for deploy at mission lapse time 1 day, 0 hours, 28 minutes. That based on an advisory from the payloads officer, Rob Kelso, that he was informed by the Payload Operations Control Center in Houston and by INSAT Satellite Control Facility in Hassan, India, that the transmitter data, the ground support network, and all elements to participating in supporting deployment are receiving very positive indications from the vehicle and all our data that systems are performing nominally and are in good shape for deployment. And deployment would occur nominally 45 minutes from now. 15 minutes later, the orbiter would perform a separation burn of the OMS engine. On orbit 17 at mission elapsed time 1 day, 0 hours, 31 minutes. This is Mission Control Houston.
Jeff, are you going to be looking at us anymore with these flight deck cameras, or can we go ahead and turn them off?
We have no more TV passes between now and the deploy.
Okay, we'll secure those then. Thank you.
This Mission Control Houston, NASA Select TV is now providing a playback of the pre-deploy video. And in a few more minutes, the Challenger will perform an automatic maneuver to the deploy attitude. This will be the 5th deployment of a satellite using the payload assist module from Space Shuttle. The payload assist module has been in use since late 1980 in a variety of unmanned expendable launch vehicles. Its first use aboard the Space Transportation System was on STS-8 when the Satellite Business System satellite and ANIC communication satellite were launched from the spaceship Columbia on November 11th and November 12th, respectively, last year. And earlier this year, the Challenger launched another ANIC and Indonesian satellite Palapa on June 18th and 19th of this year. Mission elapsed time 1 day, 0 hours, 35 minutes. This is Mission Control Houston. This Mission Control Houston, Flight Director Randy Stone just checked with all console positions here and asked for go, no-go votes for deploy, and received a unanimous go from all positions. Mission lapse time 1 day, 0 hours, 40 minutes, and deployment scheduled to occur in approximately 36 minutes. This Mission Control Houston, we're expecting to give the crew a go for deployment during this pass, although there will be a voice pass available through Yargity, and Yargity will be the last.
Challenger, we're going off Tidris in 30 seconds. We'll still be with you through Botswana, and you are still go. PAM, inset, and ground.
Understand, we're still going. Things look good on board. We'll see you later.
Great.
That communication from Mission Specialist Guy Bluford. We're about 3.5 minutes away from LOS through Botswana. Then we will reacquire voice only through the ground station at Yargity. The Yargity Pass will be the last voice contact we have with the Challenger crew prior to deployment. Mission lapse time now, 1 day, 0 hours, 43 minutes. This is Mission Control, Houston.
Challenger, we're 30 seconds LOS. Talk to you through Yargity at 0 plus 59 in about 12 minutes.
Roger, Houston, and we'll see you later, and things still look good on board.
Power at 1 day, 1 hour, 11 minutes mission elapsed time. 1 day, 1 hour, 13 minutes mission elapsed time will initiate terminal sequence start. And looking for deployment at 1 day, 1 hour, 16 minutes, 54 seconds mission elapsed time. Terminal sequence start occurs as follows. Mission Specialist Guy Bluford will initiate that terminal sequence start by some keystrokes on the computer at the commander's position, the forward left front seat in Challenger. Subsequently, he will. That will occur about 3 minutes before deployment. Subsequently, he will do a pre-arm keystroke sequence. Meanwhile, Mission Specialist Dale Gardner will arm the payload assist module from his position at the aft port payload station. At his position in the commander's seat, Mission Specialist Guy Bluford will then perform some keystrokes to arm and fire the deployment sequence. At the aft crew station, Dale Gardner will then take some actions to deactivate the ASC airborne support equipment and PAM heaters. The crew will then change positions and prepare for the separation burn of the orbital maneuvering system. The payload dialog continues to indicate nominal functions. All the participants and all the systems, the ground network, the spacecraft, and the payload assist module are all go for deployment. Mission control teams and all the players here are ready to support and looking forward to deployment 20 minutes from now. Mission elapsed time presently 1 day, 0 hours, 55 minutes, and AOS through Yargity in about 3 minutes. This is Mission Control, Houston. This is Mission Control, Houston. We're less than a minute away from acquisition of signal, and Payloads Officer Rob Kelso has just advised the flight director that the satellite control facility at Hassan and the Payload Operations Center here in Houston are both go for deploy. And we should have voice momentarily at Mission Labs time 1 day, 0 hours, 59 minutes. This is Mission Control Houston.
Challenger, Houston's with you through Yargity for 8 minutes. The PAN, the INSAT, and the network are still go, and we'll just stand by now and be quiet and listen to anything you want to say to us.
Roger, Houston, read loud and clear.
That's good news.
And the maneuver's complete. Attitude now.
Okay, Dick.
Okay, Jeff, starboard restraint is out, port restraint is coming.
Okay, we're sticking with you.
The report of those two restraints having been removed verifies that the crew has initiated a mechanical sequence start. The first event following mechanical sequence
Port
start.
restraint out. Fins coming up.
Following this Mission Control Houston, following mechanical sequence start.
Stabilize. What are you up here?
Great. It may be a lot easier than in the Sims, but I'll bet the visual is a lot better.
Okay, Jeff, I can see all sides of the spacecraft now rotating by, both solar panels, the CS fan, and the solar sail VHR sides all look good.
This is Mission Control Houston, payload officer Rob Kelso, shown in the center of the screen on NASA Select now, just verified that the mechanical sequence start appears to have been completed up to the point where the satellite goes on internal power.
Challenger, we are 45 seconds to LOS. Hope everything continues as well as it's gone so far. Have a real good deploy, and we'll look forward to talking to you at Hawaii 1+24.
Copy, Houston, and right now we're still looking good in the cockpit, and understand we're go for deploy.
Great, you are go for deploy, and have a good one.
Houston.
This is Mission Control Houston at 1 day, 1 hour, 7 minutes Mission Labs time. We've had loss of signal through Yargity. We're about 9 minutes away from deployment, and it's going to occur out of contact with the ground. The next advisory we'll have from the crew will be at Hawaii in about 17 minutes, and that will be the first indication on the level of success we will have enjoyed with this deployment sequence. Once the crew initiated mechanical sequence start, the subsequent events were at 32 seconds opening of the sun shield. A minute and 20 seconds later, the starboard restraint would have been removed. At 2 minutes and 8 seconds following mechanical sequence start, the port restraint would be removed, and those two events were reported by Mission Specialist Dale Gardner. Then at 2 minutes and 52 seconds after the start of the mechanical sequence, the spin rate would have begun and should have achieved a rate of 40 revolutions per minute, and Gardner did verify that that the spin rate had been initiated, and described the appearance of the payload as it rotated on the spin platform. Ejection from the payload is expected to occur at Mission Labs time 1 day, 1 hour, 16 minutes, 54 seconds. orbit 17. Marmon clamp will be released by explosive bolts, and the payload, which will be spinning using centrifugal force to stabilize itself, as does a gyro. The payload will be popped out of the payload bay by a series of springs, and will separate from the payload bay at approximately a rate of approximately 3 feet per second. 15 minutes after we separate, the orbiter will perform a separation burn. Prior to the PAM's perigee burn, the orbiter is going to move to an attitude that is intended to protect the windows from erosion by the PAM exhaust plume. The orbiter will be nose forward with the payload bay away from the Earth. The PAM will be ahead of and slightly below the orbiter, with the orbiter pitched up 50 degrees to their common line of sight. We are about 6.5 minutes away from payload deployment, and sitting and waiting for the next voice contact, which will occur in 14 minutes through the ground station at Hawaii. Mission elapsed time 1 day, 1 hour, 10 minutes. This is Mission Control Houston. This is Mission Control Houston at mission elapsed time 1 day, 1 hour, 15 minutes. The NASA Select TV right now is showing a view of the payload's Officer Rob Kelso, who is obviously a prominent participant in the process of preparing and deploying the INSAT and the payload assist module. And he is clearly anxiously looking forward to receiving data through the ground station at Hawaii to indicate whether the deployment has in fact occurred as we expected. And we will have acquisition of signal through Hawaii in approximately 8 minutes. And deployment is to occur in roughly 30 seconds from now. This is Shuttle Mission Control at 1 day, 1 hour, 17 minutes. Nominal deployment of the INSAT should have occurred just about a minute ago. And assuming all events have occurred on schedule, the crew should now be repositioning themselves for preparation for an ohms burn, which is to occur in roughly 14 minutes from now. That scheduled ohms burn is of planned duration of 6 minutes 11, a 6 second burn. Changing velocity by 11 feet per second and producing an orbit measuring approximately 166 by 160 nautical miles. The PAM-D burn is to occur at a mission elapsed time of roughly 1 day, 2 hours, 2 minutes, and the duration of that burn is 85 seconds. This is Mission Control Houston at 1 day, 1 hour, 22 minutes mission elapsed time. Just about 2.5 minutes from acquisition of signal through Hawaii, and our first advisory as to the success of the PAM deployment. Also, the ohm separation burn will Again, assuming nominal operations to that point, that ohms burn will occur in sight of the ground station at Hawaii. The crew will have recorded the PAM deployment on videotape, and there will be a TV dump of that video at Mission Labs time 1 day 3 hours, and playback at Mission Labs time 1 day 3 hours 20 minutes. And we should have voice contact in roughly 1 minute, and looking forward to ignition for the separation burn of the ohms engines in about 8.5 minutes at Mission Labs time 1 day 1 hour 23 minutes. This is Mission Control Houston. Mission Control Houston, we have AOS and we'll have voice in a moment. Payloads officer says...
Challenger Houston with you through Hawaii for about 8 minutes.
Roger, Houston, and we're happy to let you know that INSAT was deployed on time with no anomalies, and the satellite looked good.
Well, that's excellent. Good show. You guys have maintained the shuttle's perfect record. You have a report for us?
Roger, attitudes first. The current was roll 4, correction, 345.07, pitch 72.79er, yaw 335.30, rates in roll 0, in pitch minus .002, in yaw plus .004.
That was rock solid then. Real good.
And Houston CDR, we're targeted for the burn. We're sitting at burn attitude. You can take a look. And Jeff, you can report to the spacecraft folks that the spacecraft was alive and well when it left, because at about 1 minute and 20 seconds I saw the automatic mutation control system come on and I saw a couple jets fire. So it was working good.
Okay, that's good news. I guess that's the first time we've been able to see something like that. That's real good.
Also, we had no vibration in the vehicle that we could sense during the spin, but we had a real good clunk that we all felt through the orbiter structure right at deploy.
Okay, that's interesting. Okay, and from down here, things look good for your burn.
Roger, Jeff. Thanks a lot for looking. We're a little over 4.5 minutes from TIG.
Challenger Houston on your ohms valve configuration.
Roger, and let me check the pad real quick. Roger, Jeff. We're A open, B closed. Thanks for checking.
You got it.
Okay, Houston, 2 engines non-pressed, both P valves are open.
Okay, we see your configuration. It looks good for the burn.
It's Mission Control Houston, just seconds away from the ohms burn now, and it should have just now started. A 6-second duration. The propulsion systems engineer Wayne Hale reported both engines look good, and nominal start, nominal cutoff of that burn. And we're now awaiting verification from the crew.
Okay, Houston CDR, the burn looked nominal to us.
Okay, I think it looked good down here. We're 15 seconds LOS. We'll be out of touch for 2 minutes, then speak to you through the States.
And it sounded like from the aft that it was spectacular to look at it.
That's what all the people say, I guess, who are lucky enough to see it.
It's Mission Control Houston. We've had LOS loss of signal through Hawaii. We'll reacquire through Buckhorn in about a minute and a half. That debris foams burn intended to drive Challenger away from the payload assist module so that when it performs its burn in about 45 minutes, it will be of adequate distance from the Challenger to preclude the chance of any plume damage to the vehicle.
Challenger Houston's back with you through the States.
Roger, Houston, and the post-burn gimbal check would look good on both engines.
Thanks.
And Jeff, not wanting to rest on our laurels. We're down in the mid-deck getting ready to get the CEPA started.
Okay, you guys are keeping busy. Great.
And Houston CDR, we're about to start up the feds for the CEPA operation. Free comes benefit.
Okay, thanks for letting us know.
MS1.
Go ahead.
Okay, Jeff, you can pass on to the CEPAS people that the system status check on sample number 3 started at 1 day, 1 hour, 43 minutes.
Okay, that was system status check on sample number 1, did you say?
1 and 2 were yesterday. I'm starting out with number 3 today, Jeff.
Okay, that's what I thought.
Hey, Jeff, was there a message 10 on the teleprinter? I seem to have skipped from 9 to 11 here.
Message number 10 was an entry standby. Message number 11 was an entry weather message, and message 10 was not sent up. It was held. Repeat, message 10 was not sent up.
Okay, great. I got message 11 in my hand. Thank you.
Right. Challenger, we're going to be handing over to TDRS in about a minute.
Roger, Houston.
Challenger Houston with you through TDRS.
Roger, Houston, read you loud and clear.
Challenger Houston, we're going to lose you in about 30 seconds, have about 3 minutes LOS, and pick you up at Botswana at 2+14. We're going LOS, pick you up at Botswana 2+14. Challenger Houston through Botswana, 8 minutes. Okay.
Okay, we're right here at the end of the system's positive 1.6, delta P3, negative decimal 5, delta P4, negative decimal 2.
Okay, 1, 2, 3, 4 are plus 0.3, plus 1.6, minus 0.5, minus 0.2.
Sounds good. Jeff, any word on the INSAT PKM?
Stand by. They're anticipating a fair amount of time, probably an hour or so, before we get a report on acquisition of that. But we'll let you know as soon as we get the information.
Okay, Jeff, thanks a lot.
Also, at some point, I have a flight note on the heat pipe experiment that's coming up in about 1.5 orbits. And there's no rush on that, but anytime you want to take that, we can talk about it.
Roger. Let's wait till Dan is available.
Okay, fine.
Hey, Jeff, where are we right now?
Well, let's see. We're talking to you through Botswana. You're right over the sort of the central part of the southern tip of Africa.
Right, thank you.
And Dick, I also have a note for you here concerning the COAS calibration, if you have a minute to talk.
You bet. Go ahead.
First of all, I can let you know the data that you got on Flight Day 1 from the COAS calibration was good, but you had mentioned something about a feeling of having less than desired vehicle response or control in one of the axes. In reviewing the data, they found that the sense switch on the rear panel A6 was in the minus X position instead of the minus Z position, and therefore the roll and yaw axes got switched. And it would be possible to repeat a COAS calibration later in the flight if you felt that it was worthwhile, but I repeat, the data that you got on Flight Day 1 was good.
Roger, I understand, and I appreciate that. Probably does explain it, and I don't think it's necessary to repeat it. It would just make me feel good, and no sense spending gas for that if we understand it. I appreciate it.
Okay, we'll pass that on.
And Jeff, any words you got on the heat pipe? I'm ready to copy now.
Okay, I guess you reported, I'm not sure who it was since it was on the other shift, but there was a report that when you at sunrise, one of the strips had turned from black to brown, one of the bottom strips. There's a couple of things on that. First of all, we wanted to know if it's possible to identify which of the bottom strips had done that. Second of all, the request was that before you start the evaluation here and before turning on any of the heaters, that you observe the heat pipes and give a description of the colors, and specifically to see if this phenomenon is observed again when you come out from the darkness into the sunlight.
Okay, Jeff, well, we've looked. I'll go down and check with Dale and show him this diagram so I can get it specifically from him. He's the only one that saw it, and I've looked at it. I haven't seen it since then, so...
Okay, it's going to be orbit 20 at about 05 hours today. I guess that it's called for in the cap. And I guess anytime you get a chance to look at it at any sunrise, it'd be interesting to get the information if you see any of the tapes that are not black.
Okay, Jeff, Dan showed me the diagram. It was the bottom tape on both of the horizontal tapes on both the evaporator and the condenser, and it was only that sunrise right after I came up to the flight deck after payload bay door opening. We've never seen it since then, so I think it was just some thermal condition that happened, in the payload bay before the doors were open and then right afterward.
Okay, thanks. I'm sure the experimenter will appreciate the information.
This is Mission Control Houston at 1 day, 2 hours, 22 minutes mission elapsed time. Loss of signal has occurred during that pass. Mission Specialist Dale Gardner inquired as to the status of the PKM, the perigee kick motor on board the PAM, which is to carry the INSAT payload into an to a higher orbit. That burn was scheduled to occur at mission lapse time 1 day, 2 hours, 2 minutes, or 45 minutes after deployment. Can't affirm whether it has occurred yet, however, due to the fact that that's burn is to be tracked by the satellite control facility in Hassan, India, and it'll be another hour or so before there's a pass over the data acquisition sites adequate to verify that successful burn or the status of that burn. We'll acquire signal in about 12 minutes through Yargity at mission elapsed time 1 day, 2 hours, 24 minutes. This is Mission Control Houston.
Challenger Houston, how do you read? Challenger Houston, how do you read? Challenger Houston, voice check. Challenger Houston, voice check.
can reach you loud and clear.
Oh, okay, good. We were having a little trouble reaching you. Some good news for you. Hassan has acquired the spacecraft, and they're preparing for spacecraft PAM separation, so it looks like the burn went real well.
Outstanding. We're glad to hear that.
And while we're on the subject of PAM and spacecraft, just to remind you that Hawaii has a VTR playback scheduled.
Roger, understand. And what do you want on the VTR playback? Portion of the VTR playback do you want?
Well, of course, we're real interested in seeing the deploy, and if you guys saw anything else that you think we'd be interested in, well, we'd like to see that too.
What I was going to do is set it up for maybe a couple minutes prior to deploy, and then let you see it spin, and then see the deploy itself.
Okay, we're expecting Hawaii at 3 hours, 0 minutes, and it's about an 8-minute pass. You can use that for planning.
Okay, will do. And Houston CDR guys going to review the VTR. There's also they also got on VTR the ignition of the ohms burn. It's not great shakes, but it's kind of interesting to watch the ohms burn light, and it follows the deploy on the tape, and we'll make sure there's time for that.
Well, that'd be great if it's anywhere nearly as spectacular as some of the still pictures we've seen of that.
Well, it really isn't on the monitors we have, but it is there, and it's worth looking at probably. And let's see, the CFOS is going well. We're in attitude. The KU band.
Break, Dick. We're 10 seconds LOS. Talk to you at Guam at 2+47.
Published, and I've got the times on that. And are we going to delete the interconnect ohms to RCS that's listed there at about 30 or so?
That's affirmed. There is no interconnect. We're going LOS. Talk to you at Guam 2+47.
Okay, see you there.
Challenger, Houston back with you through Guam for about 7 minutes. Challenger, Houston.
Houston, Challenger, read you loud and clear, how many?
Loud and clear. Couple of things for you. Let you know that Hassan has confirmed a successful PAM spacecraft separation, so it looks like it's on its way.
Outstanding. Super.
INCO tried to turn on the tags, got a developer overtemp message, and then attempted to turn it off and then on again as a way of correcting it, but was apparently unable to turn it off. And I'd like you to take a look at the tags and see if it is in fact still on, and let us know what the situation is.
Jeff, it's still on, and the overtemp light is on.
Thank you. And finally, on the VTR which you're going to play, is there a voice track on that?
Negative, Jeff. We didn't put a voice track on it.
Okay, people would like to know whether you're planning to narrate it.
Yeah, we'll add some words to it.
Okay, that's good.
Houston.
Go ahead, Dick. Go ahead, Dick.
Roger, just after we had LOS of the last, your last pass at a time of about 2+43, we saw and took a picture of two volcanoes, one which obviously is active and erupting now, and we're almost positive it's Site 7 Alpha. One looked like, it didn't look like smoke was coming out of it. However, it looked like it had a little white tip, as if we couldn't tell if it was what that was. However, the other one obviously was had a fairly sizable eruption. And I'm sorry, don't let me mislead you. It was on the west, the western part
I'm sorry, the eastern part of 7 Alpha, of Site 7 Alpha.
Yeah, we actually have a report on that. And you had some information on the teleprinter about that, the volcano Iliwerong, which is near Site 7 Alpha, and it is indeed erupting. And I guess the eruption started around August 17th or so.
Roger, the smoke was very brownish coming out, and the wind was carrying it, looked to us like essentially due west.
And originally, I guess we only had reports on one volcano, and we are trying to run down with the Smithsonian to see if there are any reports of a second one in the vicinity.
Well, we only saw one erupt, and we did sight. There is another volcano on the next island to the east that we could identify, and all we could see was it had a white tip. It was white at the tip of it. I don't and can't explain any more than that. We just couldn't see with the resolution of our eyes.
Oh, okay. So as far as the actual eruptions, then you're saying that you saw one.
That's correct.
Okay, fine. Thanks. Challenger, we're 30 seconds LOS. See you at Hawaii with TV at 3+00. Message from GNNC. Could you please take the star trackers to track?
We sure will.
This is Mission Control Houston at Mission Elapsed Time 1 day, 2 hours, 59 minutes. Just a minute away from acquisition of signal through Hawaii and some expected downlink television of material recorded previously showing the INSAT deployment and some other scenes selected by the crew.
Challenger, Houston with you through Hawaii, 8 minutes.
Roger, Houston, stand by.
Challenger, Houston, INCO says we're ready to receive TV whenever you want to send it down.
Okay, Houston, we're getting ready to put it on, send it down. Okay, Houston, we're going to try and give you 4 playbacks. One indicating, showing the INSAT activation and spin up. The second one, just beginning of mechanical sequence. INSAT activation and sun shield opening. Second sequence should be the beginning of mechanical sequence and spin up. Third sequence should be the spin up and deployment, and the fourth sequence will show you the arms burn after the deploy.
Okay, we're looking forward to it.
Okay, here comes INSAT activation and sun shield opening.
We got a very small bit of a picture, and then, here comes something again.
Okay, stand by. I guess I'll have to tell you what this one is. This was the very end of the end effector checkout.
Yeah, it looked a little bit strange there from the PAM point of view. There we go. That's the FDA and the sun shield again.
Yeah, it's permanent, and we should see the sun shield opening here pretty quick right after INSAT activation. Okay, you can see the sun shield opening here. And here we have the sun shield fully open. And the spacecraft was not too visible there because we were in darkness and the payload bay lights shine up, and of course the satellite being inside the sun shield was kind of hidden. Okay, guys, stepping the tape ahead here for you. Okay, this sequence of the tape shows you the beginning of mechanical sequence and spacecraft spin up.
Okay, we're watching.
We just got an antenna message, Jeff.
We see it, we'll get to you.
You can see
we have a smooth spin up. It's spun all the way up to 40 RPM and stayed very stable right at 40 RPM. Okay, the third sequence is going to show you the spin up and deploy here. Yeah.
Okay, we're going to be watching. Can you please put the TV system into the command mode? And Inco thinks he can clean up the picture a little bit from our point of view.
That guy was a little too late. He's going to back it up a bit for you. And while he's doing that, Jeff, once we start tilting that camera up, of course, we're deploying very close to the sun, so you'll see the picture is not optimum.
Okay, we understand. And you said at this point when it was spinning, you felt no vibrations or anything at all?
Negative, with no vibrations at all. We did get a large pump right there at deploy itself. But you can see that the spacecraft deployed very smoothly.
And there you can see the sun's reflections. The two sides that have the solar arrays on them do not reflect the sun as much as the two sides that have all the gold foil.
Yeah, that's interesting.
Bill Thornton was up here on the flight deck with 16 millimeter with our new see-through zoom lens on it, and we think he may have been able to zoom in close enough to keep a lot of the sun shafting out of the picture. So we may have some good films that we look at post-flight.
Yeah, that'll be great, and of course you won't get the blooming. From here, it looks like it came out real solid, no sign of any wobbling or anything. Is that your subjective opinion, too?
That, as a matter of fact, I watched for that and could see no wobble whatsoever. And as I mentioned earlier, right on time at a minute and 20 or a minute 25, whatever, we saw the ANC start up.
Okay, we're 15 seconds LOS. Why don't you hold off the next tape? We're going to configure Goldstone for TV, and we'll be with you there at 3+11. That'll be about a 3-minute LOS. We're going LOS now.
Okay, and thank you very much, sir.
Challenger Houston's back with you through the States. And hold off on the TV until we give you a go.
I understand, Houston. Now, Houston CDR, would you like to have these initiation times for the gas alpha?
Stand by, Dick. Dick, yeah, we would like to get those initiation times at some point.
Okay, I can read them to you real quick right now if you have a pencil. I'm on page 4-2, flight supplement 4-2 at orbit ops.
I'm with you, read away.
Okay, the first time is 1 day, 2 hours, and 35 minutes. The relay 03 is 37 minutes. 06 is 37 minutes. 07 is 38 minutes. And then the 07 hot back to latent is 3 minutes.
Okay, we have the times.
Okay.
Okay, Challenger, we're ready for TV. And on A7, could you please put the TV to command? Because we have to clean up some of the asynchronous signal so we can get a cleaner signal down here.
Okay, your TV's in command, and we're going to roll it for the ohms burn. Jeff, can we roll this tape? Houston, Challenger.
Go ahead.
Can we go ahead and roll this?
Yes, please. We're ready.
Here we go.
This is camera Delta, Jeff.
And you'll note on this one that you'll see the start of burn and just a flash, and that'll be about it. It's only a 10-second burn. So you can see the start of the burn there, Jeff.
You probably also saw a jump in the picture. That was the camera jumping when the ohms engines lit, and we sure felt...
You want to run that ohms burn by us again once more, do you think? I'm not sure a lot of people caught it.
we'll run it back again, Jeff. It's somewhat underwhelming. Here we go again, Jeff. You can see that you saw the great big flash at the start of the burn, and that's about it that we picked up on the VTR.
Yeah, I think the audio reaction in the Mocha this time indicated a lot more people saw it, so that was good. Thanks a lot. Hey, I have something for you on that antenna message. Turns out there's a failed discrete on one of the antenna switch positions, I believe at the lower right. The antenna is working, but when SM sends that antenna a command, it does not get a feedback. And so although that antenna is in control, the SM doesn't see it, and it announces a miscompare. And apparently we're going to get that every time that antenna is called out. And INCO's thinking about something to do to make sure you don't get a lot of messages, especially during sleep period, and we'll get back to you on that later.
Okay, Jeff, appreciate you saying that. We did get one antenna message last night. It turned out that Dan and I were up at the time, so it was of no significance, but if we could avoid that tonight, that'd be a real help. Thanks for telling us.
Yeah, they're going to be working on that, and we'll just have to let you know what they come up with. Okay, Challenger, also got something for you on the water system on R12.
Okay, go ahead.
Tanks Charlie and Delta are now topped off, so you can go ahead and reopen supply H2O tank Bravo inlet valve.
And Jeff, CFIS update, Dan and Bill are in the airlock doing the CTA prep on sample 3 Alpha, and I'm doing the prep on the sample 3 Bravo. And just for your info, it looks like the kidney cells are, I was able to get them stirred up into a very homogeneous solution. They were not very unhomogeneous to start with, but it looks real good, and we'll be putting them in a few seconds.
Sounds like things are going real well.
Maybe that word is non-homogeneous. I don't know.
Well, if it's one solid mass, then it's probably homogeneous.
Okay, Jeff, and we're starting the change-out sample portion of sample 3 at time 1 day, 3 hours, 18 minutes.
We copy, Del. Challenger, we're LOS. 30 seconds. Talk to you through ascension at 3+39.
Roger, Houston, and I'm going to be passing on a question from Bill Thornton about the microbiological sampling automatic timer for the PI, who I think his name is Dwayne Pearson, when we get to Ascension.
Okay, that was the microbiological what, Dick?
The microbiological sampling DSO, a question about its automatic timer. It does not appear to be working, and Bill needs some instructions about the sample time.
Okay, we'll see if we can have some support for you.
Roger. He intends to do it manually. He thought it was for 8 minutes. The timer had been set for 10 minutes. He'd like for Dwayne Pearson to confirm the sample time.
All right, we'll see what we can find out.
Thanks a lot, Jeff. Houston, Challenger.
Challenger Houston with you through Ascension for 7 minutes.
Roger, Houston, read you loud and clear.
The E&D folks would like to get a test out of the KU band, and I've got a very short procedure for you if you got a minute.
Roger, stand by, Houston. Okay, Houston, go ahead.
They'd like to do a radar self-test, and if you can, on panel A1 uniform, put the KU band mode switch in a radar passive, and then take the control switch to panel and command, then INCO will do the rest of it for you.
Okay, Jeff, I did that. See if it took.
Thanks, Dick.
And Jeff, right at the tail end of that other pass, I was passing on a thing from Bill Thornton. He's been busy downstairs with Dan and Dale on the CFA sample preparation and asked me to pass on that request. Did you get all of it?
We did. We have somebody standing by who hopefully will be able to discuss it. We understood that Bill was going to come online and talk about it a little bit.
Well, as I say, he's downstairs busy and in the midst of the preparation, and they just can't stop. But let me repeat what he asked me to pass on to you. He said that the automatic timer for the microbiological sampling was not working. It ran for several minutes past the time that it was set for, and did not cut off. He had understood that the sample time was 8 minutes. He may be mistaken, but the timer had been set for 10 minutes. He told me that he intends to manually do the sampling and requested a confirmation as to the sample time. Over.
Okay, I think we understand the question completely. And I guess all I can tell you now is they're trying to raise somebody who can answer the question for you. And right now we do not have an answer. I'm sorry.
Okay, no problem, Jeff. We were so close to LOS, I wasn't sure that you got it. But that's what he passed on to me. And maybe later, if there are any more questions, I'm sure he'll be available to talk. Bill has been extremely busy both these 2 days and has not even been on comm down there working full time.
Having a good time, I hope.
Oh yeah, he's having the time of his life.
Great, good to hear it. Challenger, LOS 30 seconds, talk to you at Botswana, 3+50.
Okay, Houston, we'll see you there.
Challenger, Houston with you through Botswana, 8 minutes. Challenger, Houston, how do you read?
Houston, Challenger, loud and clear, how many?
We read you, Dick. I wasn't sure if we maybe just caught the tail end of a transmission you were making to us about being off the southwest tip of Africa. If I got my geography right, I think that area is the Kalahari.
Roger that.
Oh, that sounds neat.
I believe that was in the Hammersley.
Probably McDonald's then.
People, the set voltage for...
Okay, we've got that, Dale, thanks. Challenger, we're going LOS in about 30 seconds. We'll talk to you through Guam next at 4 hours, 22 minutes. Or I should say the Orbit 2 team is going to talk to you because Orbit 1 is going to go off now and probably go home and go to bed. It's 5:30 in the morning. It's been nice working with you.
Roger, enjoyed it. You
okay.
You guys a lot.
Okay, be seeing you.
This is Mission Control Houston. Loss of signal at Botswana. The crew doing a little sightseeing as they came across the southern tip of Africa. Apparently spotting the long rows of dunes, also known as the sands of Kalahari in Namibia. Next station is Guam in 22 minutes. At 1 day, 4 hours. Mission Control Houston. Mission Control Houston. Acquisition of Challenger upcoming in a few seconds through Guam Island on orbit number 20.
Houston, Challenger, how do you rate?
Challenger Houston, Crystal team with you through Guam for 7.5 minutes.
Roger that. How y'all doing?
Doing fine, Richard. When you guys have a minute, I have an answer to the question you folks had on the medical DSO.
Okay, Bill is not on comm. Could you give it to me and let me pass it to him?
Roger. It appears that the 10-minute timer doesn't really bear a relation to the amount of time for each sample. Each sample was supposed to have been worked on for 2 minutes per sample.
Okay, I understand if Bill does it manually, the sample should be 2 minutes per sample. Is that Charlie?
That's a Roger.
Okay, let me pass that on to Bill, and if he's got any questions, Fish, I'll get him on the hook and let him talk to you.
Okay. Challenger Houston.
Hey, Fish, a couple words on CEPAs.
Okay, go ahead.
Okay, first of all, the same situation that occurred yesterday with the sample pump standing forward and not stopping halfway through the collection is occurring today, as you all predicted. We're pressing on as you suggested. And just to keep you up to date with where I'm at, we are now 18 minutes to go in the 50-minute collect on sample 3.
Roger, Dale, we copy. Also, when you folks have a moment, we have some comm reconfiguration switches for you.
Okay, this is a good time, Fish. Go ahead.
Roger, Richard. When we left you last night, we configured over to state end coverage just before we put you to bed, and we would like to undo that and put us back in the operational mode for our standard TDRS data transmissions. And we'd like you on panel A1L to return to the on-orbit configuration, specifically the S-band PM mode rotary switch to TDRS data, the NSP data rate switches, both of them, to low, and finally the 2 coding switches to on.
Okay, those switches have been set, and do you need a panel in command or not?
Negative, Richard. Just that switch configuration will do it for the time being.
Okay. And Houston CDR, be advised the TAC-IN nav test has been started, and I'll be doing that for the next several hours. If you see me out of sync, it's an awful easy procedure to get out of sync on, so please let me know.
Roger, we'll do that, Richard.
Okay, and Bill is busy right now in the middle of another med experiment, and so I couldn't pass on that information to him, but as soon as I can, I will, and he'll, and if there's any problem, I'll get him to talk to you.
Roger, and we're about 1 minute and 30 seconds from LOS here, and we'll see you next at Hawaii at 11, or at 9+25. Challenger Houston with you through Hawaii for 7 minutes.
Roger, Houston, loud and clear.
Challenger Houston, we'd like to confirm that for the TAC-IN test, you are on the upper antenna.
That's firm, Bill. I am on the upper antenna on all 3 TAC-INs. When I've had time to, well, it looks like now, I was going to say that I have not seen any of the TAC-INs locked. I notice now that all of them have the same azimuth readings, but I have not been watching them too closely.
Roger, we copy. Challenger Houston, we're 30 seconds LOS, and we'll be picking up TDRS shortly afterward.
Houston.
Challenger Houston with you through Tidris. Challenger Houston with you through Tidris. Challenger Houston through Goldstone UHF. How copy?
Houston Challenger, that time we heard you.
We heard your first two transmit.
Clear.
Roger, we're having trouble hearing you on Tidris, Richard, but we hear you now loud and clear.
Roger, Roger. To Bill Thornton, and he said okay.
Roger. And Challenger Houston, just a note for you, we have locked up on the KU band for the first time.
Roger. Good work.
And Challenger Houston, we're with you through Tidris again. How copy?
Roger, loud and clear.
Okay, Richard, we've got you loud and clear too. Challenger Houston, note for Richard on the TACAN test. We need you to go with the station 106.
He's in the process of doing that, Fish. Roger, thanks for the catch. I, for some reason, I did not hear the time tone when I had said it, but we're in 106 now.
Roger.
Houston, Challenger.
Challenger Houston, go ahead.
Okay, Fish, on this heat pipe experiment, as best I can tell at times looking at the caps, I'm planning on starting it at 5 plus 15. And would you verify that you expect sunset at about 5 plus 50? That's what it looks like in the cap.
Stand by on that, Dan. And just a note for you, as part of our Tidris testing, there will be some periods coming up when we go in and out and have intermittent comm with you.
Okay.
Challenger Houston, for Dan, it appears that sunset will be about 5:51, 5:51.
Roger, thanks.
Challenger Houston, with you through Botswana for 8 minutes.
Roger, Houston, loud and clear. And Fish, we fired up the heat pipe on time at 1 day, 5 hours and 15 minutes. And we're going in 12 minutes into run now. And we have the evaporator. The second tape is up to blue, tape number 2. And the condenser, tape number 1, is just about all blue. It starts changing color on the left end and progresses down towards the right. It changes pretty much all at the same time, but it becomes a little more obvious on the left end first.
Roger, Dan, and we expect you to keep a close eye on those colors.
We're doing it by committee.
Roger that.
And the committee has 3, so there's always a tiebreaker.
And Houston, MS1 change-out sample for sample number 4 occurred at 1 day, 5 hours, 4 minutes.
Roger, we copy, Dale.
And Fish, as far as the CTA prep stuff went, Bill and Dan finished up each of those right on time, and both of those samples are now in the storage module.
Roger, Dale, that sounds good.
And Fish, on the heat pipe, on the condenser, the vertical tapes, tape 1, are also have turned blue, and there's very little gradient with them, so it's pretty much an even temperature distribution over the whole condenser.
Roger, Dan, we look forward to seeing those pictures. Challenger Houston, we're 40 seconds LOS. We'll see you at Indian Ocean at 5 plus 36. Challenger Houston, with you through Indian Ocean UHF. How copy? Roger, Dan, we've got you loud and clear for about another 4 minutes.
Okay. And fish on the heat pipe, it looks like it's pretty well stabilized out now with the third one on the evaporator, blue getting ready to turn, and the looks like it's found on the borderline between the third and the fourth tapes. And on the condenser, the second tape is very blue, and the third one's getting ready to come around and start turn into a kind of brown. It's been that way for quite a while now. Just for your info, about the first 10 or 11 minutes, we put comments on the ICOM recorder, and since then we've just been letting the camera do its thing.
Roger, Dan, we copy.
And fish separation voltage on sample number 4 is 256.
Roger, we copy 256 sep voltage. Challenger Houston, we're 30 seconds LOS. We'll see you at Guam at 5 plus 5 Niner.
Roger, Houston, see you there.
Mission Control Houston, loss of signal at Indian Ocean Station. Guam will acquire Challenger in approximately 17 minutes. Earlier in this 20th orbit, the first lockup with the K-band, KU band on the teeters through Challenger and the White Sands tracking station was accomplished. The first of many such tests that will be run over the next 3 or 4 days to ring out the teeters tracking satellite in its various modes. At 1 day, 5 hours, 42 minutes, Mission Control Houston.
Challenger Houston with you through Guam for 6 minutes.
Roger, Houston, and I'd like to talk to you about APU hydraulics.
Roger, go ahead.
Okay, we got a Spec 86 message at a time of 1 day, 5 hours, and 47 minutes and 11 seconds. When I called up Spec 86, hydraulic accumulator pressure on system 1 was dropping very rapidly and was, I don't know exactly the number, but it was, if I recall, 1,700 and something. And thinking that I remembered that the limit was higher than that, I went ahead and turned on hydraulic circ pump number 1 and then went to the pocket checklist, and sure enough it said, don't let it get below 1,930 PSI, I think. We then went to the MAL. I guess the circ pump stayed on probably a minute or so while I was getting out the MAL. And it said to turn it off on page 113 of the MAL Block 2. I did turn it off, and at that point, Dan and I saw that the accumulator pressure now is holding steady at about 2280. Coming out of there, there's no exact answer for this because the accumulator pressure never increased above 2,500 PSI. So right now the system is stable. The pressure was decreasing very rapidly, and I'm afraid I can't add any more light to it than that.
Roger, Richard. We'll take a look at that and get back to you.
Okay, and if you're recording data and want to go back and look at it, the time again was 1 day, 5 hours, 47 minutes, and 11 seconds when we got the alert. I don't know how much before that it started down.
Roger.
And Houston, CDR.
Houston, go ahead, Richard.
It's been now, the circ pump has been turned off now for several minutes. Right after we turned it off, the pressure was 2288, and it's dropped a couple of PCM counts since then.
Roger, we copy that, and we're looking at it right now.
Okay, Doc.
Challenger Houston, we're 30 seconds LOS. We'll see you at Hawaii in 7 minutes.